we'll work together on those files to be able to actually see how we can do some simple programming tasks on MATLAB without being without having sort of a very good program introduction to MATLAB. We just want to make sure everybody already has the software, the trial version. So if you work in a university or you're studying at the university, especially in the UK here, if you're doing anything related to like engineering or science, you have access to it freely. But for those of us that do not work in institutions where you have access to MATLAB, you can download the trial software. The link to download the trial software was put in Google Classroom, but I was hoping that we can also put it in the chat box here so that people can then get the link to download it. So if Augustine can please put the link on the chat box and see people can download it, and I want to be able to be sure that everyone has downloaded it. And then if anyone has any questions on downloading or opening the MATLAB software, or do let me know, please. So we're going to just make sure we've got all the software details sorted between now and 12:30. So has everyone downloaded the software? You can either type in the chat box yes, or use thumbs up or something so that we know that everyone is ready to go. No reactions. Do we all have the software downloaded? Or if you already have it on your computer, maybe to your university, that's also fine. Okay, thank you, Nnamdi. So not yet. So it's in the program for today. So let me see if I can get the link for you as well. Okay, thank you. So Augustine has sent it into the group. So if everyone can click that link and download the software, please. So the instructions are also in the chat for anyone interested. Please do try to download the software once you've got it sorted and it's activated and open. Do let me know and then we can start. Monica, so can you unmute and how far did you go before it said access denied?
Okay, hello, please, Doc, I click on the website on the link you sent, and then it took me to a page where I can enter my university email. Okay. And then I press, yeah, so I put in my university email and I click continue. It took me to another page where it shows me that location, which best describe you. Are you at least 30 years or older? Which I feel South Africa. I'm a researcher, and then I'm older than 13 years. And then I click create. And then when I did that, it showed me denied access.
Okay. Okay, let me see if we can make it.
I don't know, maybe because I'm from South Africa.
Yeah, I don't know if there is but
yeah, is he telling me you don't have permission to access htww?
I think it should be location issue, but instead of if you use a personal email account and not the university one, or do you?
Okay, you want me to use
have a university license? Yes. Yeah, so can you share your screen?
Because I'm using my phone, so how do I share my screen?
Okay.
Except I go to my system.
So I think, are you trying to log in to access it on your phone or on your computer?
On my phone.
No, it's better if you're doing it on your computer, because you want to do some program. You won't be able to follow through with your phone, unfortunately.
Okay, let me put on my laptop. Let me put on my laptop now. Okay.
Has everyone else been able to install it? So we may just start. Are there any other installation issues? Or if you've all installed it, please let's have thumbs up, some reactions, so we know everyone is good to go. So I'm going to assume that everyone is good to go, and Namdi is. So how about Shmuel, Abel, Chisim Dindu, and Patrick, and Chineye as well. Is everyone ready to go with the laptop with the installation? Okay, because of time, at least we know one person is ready to go, so we are going to just start, and everyone else can join us as we go ahead. So I'm going to be sharing my screen. If you have any question, put it in the chat box. So if you were trying to install it just before I do the presentation, this is the page, and then you can just click here to get a free trial, and then you can follow the links and download the 30-day free trial and continue from there. So first, I'm just going to go through a quick presentation before we start. So as I've already been introduced, I'm Khadijat Olorunlambe, and I work as a teaching fellow at the University of Birmingham. And so the outline for today is we're going to have an introduction to MATLAB first, and then we go to the MATLAB basics. So the desktop, the interfaces, the simple commands you can write on the command line before. So all of this should be done by 1 p.m. And then after, take a short break and we'll do the data visualization, our first interactive session. And then we'll also do machine learning. So a slightly more advanced way of using MATLAB to classify and do regression for predictive analysis. And that's all we'll be doing today. So, but first, what is MATLAB itself? So it's a programming and numeric computing platform that is used by engineers and scientists worldwide. You can use it to analyze your data, create models, and develop algorithms. So I'm going to play a short video that sort of takes you through some of the things that MATLAB can do. It's a short, less than 2-minute video. And then the MATLAB capabilities. So some of the things that MATLAB can do is you can analyze and visualize your data. So if we have a data, so we're going to be looking at this today. When we have some data, how do we visualize them and then analyze them based on what we can see? Also some programming, so you can create some scripts, functions, and classes. We won't do so much of the scripts, but we'll actually be using a script to be doing our visualization today. So you'll see how you use scripts and then classes as well. And then external language interface. So if you're familiar with languages such as Python and Java, you can use MATLAB with those languages as well and some other languages as well. And the applications of MATLAB, just some examples. There is a lot of them. If you go to the website, you will see a lot more. I've just pinpointed some applications and capabilities here. So you have the data science, excuse me, you have machine learning and signal processing. So now just a little video. So just want to make sure everyone can hear. I've shared my screen.
Millions of engineers and scientists use MATLAB to analyze the data, develop the algorithms, and create the systems that shape the world around us. At the heart of MATLAB is a high-level programming language that lets engineers and scientists express matrix and array mathematics directly. MATLAB provides a vast library of toolboxes that spans everything from signal and image processing, control systems, wireless communications, and computational finance, to robotics, deep learning and AI, and more. Created specifically for engineers and scientists, MATLAB is designed for the way you think. Easy to learn and use, it lets you express your ideas directly and puts the tools you need at your fingertips. Explore ideas quickly. See results and visualizations right next to the code that produced them. And only MATLAB includes pre-built apps and allows you to easily build your own, for when point and click is the best way to analyze and design. Extend MATLAB with thousands of packages and toolboxes shared on GitHub and elsewhere. Then deploy your work on cloud and enterprise systems, into Simulink, or automatically generate code that runs on embedded devices. From researching the world around us to creating next-generation intelligent systems, millions of engineers and scientists use MATLAB to shape the future. What will you do with MATLAB? Millions of engineers and scientists.
So I believe that little short video has given us a short overview of what you can do with MATLAB. As we can see, there's a lot that can be done with MATLAB, starting from the basics to very advanced. So we're going to be starting with basics today. And then if you are interested, you can research for them and do more. And I'll also show you how you actually can find out things that you want to do on MATLAB, documentation to find out information, and you can go on from there. So starting, I'm going to open my MATLAB software. So I've got my MATLAB open. I had some stuff that I was working on initially, so I'm just going to quickly close all of those. So if there are any questions, please drop in the chat box. If you need me to slow down, please do let me know. So if you open your MATLAB, if you've all got your MATLAB installed and you've opened it, this will be what you would have opened. And I'll move this here. This will be what you will have opened. This is the interface that you should be seeing. And you can see there's even something here that says, because I haven't used MATLAB a lot on this computer, it tells you new to MATLAB, resources for getting started. So it's always good to click this. So you can click this where it will take you to a page where you can see things that you can use to start. So we will be going through these basics right now. Actually, so these are all we're going to be going through these tutorials. I know this was put on the Google Classroom, but just in case people didn't have time to go through them, we'll be going through these basics actually on today for the next 20 minutes or so. So you have your MATLAB. We have what we call here a command window. So when you write things on the command prompt, this is where we say you write things in the command window. So this is where you just type anything and it's going to show up on the right. So the right here is your workspace. It says workspace. So whatever you're doing, this is where it's going to be getting saved. So one thing about the workspace is if you want to keep what's on your workspace, you have to make sure you save it before you delete it. So when I did clear earlier, so when you type in clear in the command line, it clears your workspace. When you type in CLC on the command line, it clears your command window for you. Here you have current folder. So you have the folder you're currently working from. So if you have the software installed and you have the ARN workshop files folder as well that was sent yesterday, what you just do is make sure you open the folder and you make it the path. So they say you can click here and add it to path by doing this, or you can just simply double click on it. So if you double click on it, it's going to open all the folders inside that, all the files inside that folder, and that's your current folder. So this tells you where you're working from. So everything you're doing will be saved here, and you have some workspaces saved here. And then details here is for when we save anything from the workspace here, it is saved as a .mat file. And when you click on that .mat file, so if I click on this, for example, example.mat, it gives me details. So it tells me all of the variables. So we call these things that we've stored in MATLAB, we call them variables. It gives me over all of the variables here, and I can actually click them to open them later on, as you'll see. Then you also have another thing, you have your plots. So this is all the plots that you're working from. So if you want to create any plot, right now we can't see and we are not able to click them because we have no variable to plot. So if you wanted to use the point and click version of MATLAB, whereby I have something on the variable here, I can just click the plot I want to make, it's going to create it for me. Then we have apps. So remember the video mentioned that we have some apps. So you would have some apps pre-installed on your MATLAB. Then if you also need some extra, you can always download and install any new app that you want, because there's a lot of apps. So you can have design apps, so to design an app yourself. You can get more apps here. You can install the app, or you can have package app. So some of the apps I have here, if you click this down arrow, it gives you the apps in terms of the class category. So this is the favorites that I have chosen, so they show up here for me to have easy access. But you can see here we have machine learning and deep learning. So all the apps that do machine learning and deep learning are here. The math, statistics, and optimization apps are here. So if you want to curve fitting, we'll be using this today. You have your distribution filter optimization or PDE modeler. If you're into control systems, so it's more for electrical engineers, you have all the kind of apps that you can use on MATLAB. For automotive, so if you want to look at driving scenarios, so you can work on this. For signal processing, you have all the apps that you can use when it comes to creating your signals, so waveforms, analyzing them. Image processing and computer vision. So you can also use MATLAB for image processing. All the apps that can be used to do that is here. Now, test and measurement, you can use MATLAB for testing and measuring stuff. You have all the apps here. You also have it for computational finance. So you can use it for in the economics modeling. Then computational biology, when it comes to like things about your genes or sequencing, you can use this. To generate code, you have the app, and then if you want to deploy it to use elsewhere, you have the apps that you can use. So every kind of apps that you have is here. And if you need any other one, you can always install them and add to your packages. So these are the three we have so far because we haven't done anything else. So first, let me just say, so the point of the basis of MATLAB is mathematical and programming. So it's numerical. So it works with numbers predominantly. So basics that you can start with if you want to do things like, let me say I want to add 3 plus 2. I'll just type in 3 plus 2 and I click my enter button. It shows me answer is equal to 5. And if you can see on your workspace, now you have a variable called answer and it has a value 5 in it. One thing with MATLAB is if you don't assign that variable to anything, it calls everything answer. So if I want, so if I do something else, it's going to change what is an answer. So if I do 3 minus 2 now, minus 1, it's going to say the answer is 2, and it changes answer into 2. But if I wanted to keep both my 5 and my 2, I have to assign a variable. So I can say A is equal to 3 plus 2. 3 plus 2. So it gives me A is equal to 5. Now I have a variable in my workspace that is called A, and it has a value 5 assigned to it. Then I can say B is 3 minus 1. Enter. Now I have another variable B, which is 2. So now I can say that I've been able to separate them. A is 3 plus 2, 5. B is 3 minus 1, 2. And I have those two variables saved. Now, one of the things, when I clicked and I entered here, MATLAB shows me B is equal to 2. If I don't want this B is equal to 2 to show on my command window, I use my semicolon. So if I say A is equal to 3 plus 2, and I put a semicolon in front, what happens is it just goes to the next line for me to enter my command. But if I look in the workspace variable, I can see A is 5 is there. Maybe because we used A before. So if I use C is equal to 3 plus 5, semicolon, I can say I've got C with the value 8 assigned. And here I don't have this shown. So I can just move on to the next command line. So if it's minus, also if you want to multiply, it's the same thing. If you're multiplying 3 times 5, remember, it just does it for you 15. If you want to divide, same thing again. 15 divided by 5. MATLAB does it and it gives you 3. So these are the basics mathematical operations you can do. You can do more advanced stuff. You know, you can start to do 2 pi r circumference of a circle. For example, if you want to do 2 pi r with your with circumference of a circle, instead of you doing 2 times pi times r, you can actually say that, okay, assign a variable for your radius and say r is going to be 5. And then I want to find 2 pi r area of a circle or perimeter of a circle. So perimeter is 2 multiplied by pi. So in MATLAB, pi is just pi. So you can always research and find what do I use to write some of the basic math symbols. And then you say 2 pi r because I've already assigned the value into r. So it's going to do that for you. It's going to give you your answer as 31.4159 because I've assigned a variable for r, so it's going to work with it. If I did not assign a variable for r, MATLAB is good that it will give you an error and tell you where you were wrong. So if I had said perimeter P is 2 pi V, for example, MATLAB will give me an error. Why? It's going to say unrecognized function of variable V. Why? That is because I haven't actually assigned anything called V, so it could not do this. It could not do this computation for me. So that's one of the things. It tells you the error, and the error explains what is wrong for you to make your changes. So if we now assign a value to V and we call V3, and then we run it again. If I want to run something that I've written before, I don't want to type it again, I can use my up arrow. If I do this, then I can see that's why I ran before. I can come back here, enter, and then it's going to run it for me now. And we can see now P has been run now, and we have 2 times pi times V. So I see a question in the chat box. So he uses, I don't know, I'll check that for you because I don't know if it works with things like ChatGPT. I know that you can use ChatGPT and other chatbots to sort of access and extract data set to work with on MATLAB, but because they are new now, I don't think MATLAB has been designed to work with them, so not for them to work together to each other, but you can get things from them that you can then work on and analyze on MATLAB. So you can use it separately, but not together, because those are still new chatbots. So they haven't designed yet to be working together that way. Hope that answers that question. So just want to make sure everyone is following so far, because I can't really see anyone. So just, let me know, maybe with thumbs up or messages if you're following, if I should continue, if everyone understand what I'm doing so far. Okay, Abel, thank you. Okay, so I'm going to move on. So that's the command window. So before we go on, I'm going to introduce what we have as our script. So we talked about scripts. So command window is good, but one thing about command window is you're always having to write something one by one and then enter. But one thing about that is really good about MATLAB is that you can write programs into scripts. So we call them scripts. You can either have it as this kind of script or live scripts. Live scripts are new and everyone uses live scripts now. So I can say new live script. So with live script, it means that I can write all of my commands, all the programs I want to do in this live script, then I'll run it at once. So I won't have to do them individually. So it wouldn't be that earlier I was having to do v is 3, do that first, assign that variable, then run it. So now I'll just write here, start by saying v is equal to 3 once again, and then next line, and then I'll say perimeter is 2 pi v. So, and then I can run this. Now, when it's a live script, it's called the live editor. What it means is that when you run it, you will see what's happening here. Also, when you work on live script, if you're making mistakes, it's going to let you know before you even run it that there might be an error, and then you can check. So if I run this, so when you work on the live editor, now remember when we opened MATLAB, we had 3 tabs. We have our home, plots, and apps. But once I've started doing a live script, we now have the live editor where we have some other functions here. So the live editor, we have, if you're opening a new file or folder or a new script or function, we want to save something, we want to compare text, so I can turn it into a text instead of it being in it. So right now it's in code form. Turn into a text, I can just type anything here, data visualization. So I can use it as information. I can provide information for you here. If you're writing your script and you want to write some basics comments initially, you can do that here before you then turn it into a code, and then you can write your code again. So when you run, it doesn't run the text, it only runs the code. So here, if I run this section, so I can either run the whole thing here, I can run it section by section. So it's good for, you see why running it section by section is good in the data visualization interactive session. But first I'm going to run the whole thing here. So when I run it now, you can see now that it gives me my results on the right. V is equals to 3, P is 18.496. It gives me it here because I haven't put my semicolons. If I put my semicolons, when I run it next, it's going to save them in my workspace, but it's not going to show them to me in the solution on the right. So if I put my semicolon, it wouldn't show them to me. So it's going to ignore v is equals to 3, but it will give me my answer here. So run it again. Now you can see that v is equals to 3 is not written down here. So on the right is where you can see. And you can see there is this 3 icons here. So I'm using this one here that shows the output on the right. You can use the one that shows the output in line. So it keeps it behind, underneath what you're using. I can also use the one that shows the output. It doesn't even show it to you. It shows it to you down here. So you can see it here as well. So you have it, so it hides the code, but it shows the output. But I'm going to use the inline one actually as we move on, as we go further ahead. So this is the first thing you can do. So now, when we have a live editor, now, the difference between this and the one that is not live is, if I wanted to open a script, if I just do a normal script here, so this is not a live editor script, it's just a normal script. So we will see the differences. So if I do v is equal to 3, and P is 2 times pi times V. I'll call this something else actually, X. So here I'll run it. So you can see that when I run it, it's going to ask me to save it first. So because it's not a live script, I'm not able to work on it unless I save the name of that script first, and then I'm going to be able to run it. But when you use live scripts, you can actually see the solutions and you can make changes to your programs until the end. When you're happy with what you have, then you can save it. But with this normal script, it's saying that you have to write what you want, give it a name before you can run it. So that's different. And that's why it's preferable for you to use your live editor to work, because you're able to do it. And you can see that I couldn't do things like text in the normal editor, but in the live editor, I can do all of these things. I can section break, we can refactor, we can add some other things. You can do tasks as well. So I can create plots inside it as well, which you'll see going ahead. Now, apart from this kind of command, what MATLAB is really used for is for matrices. That's the name comes from MATLAB, mathematics matrices. So if you want to be able to start writing your matrices and your arrays, the first thing you want to know to write is we have what we call our row vectors or our column vectors. So if I want to create a matrix of simple data, so row vector where you only have one row of data, so I can give that A, and I'll use my square bracket and I'll say 3, 5, 6, this. So I'm going to run it as a section because I don't want to run, so it's all the same. So what I'll do is here, I'll do a section break. So if I do a section break now, I'm only going to run everything from number 3 downwards. I'm not going to run 1 and 2. So I'm going to run a number 3 and I'll click on run section. So then we can see that we have a matrix that is 1 row, 3 columns, 3, 5, 6. Once again, I did not put my semicolon, and we can say that's why that is like that. So that's that. Then the next one is a column vector. If I want to do it as a column, I would actually put a semicolon. So I'll say 3, I'll use this, 5, 6. Then I'll close my brackets. Now, if I run the section, it's now a column vector. So I have a 1 column vector with 3 rows, 3, 5, and 6. And if you want to write that together, where you have rows and columns, it's just the same thing. It was on the first row, 2, 5, 6. You just semicolon. I'm going down to the next row, 4, 6, 9, and then like that. So once again, you run that section, and you can see the solution again. So that's your column. So that's your matrices and arrays, we call them. And then here, they're saved as A, B, and so when it becomes long, it will see them as something called double. That's your normal numeric matrix. And the next thing is you can then need to index and extract data from this matrices, because we have to learn how to extract data when you have a large data and you only want to work on part of that data. How do you indexing? So we call it index. We index into that data. So let's say I only want to get this second column and the 2 things under the 2 rows, but I only want 5. I want to index out the 5 in this matrix C. So I create a new variable called D, and then I'll say C. I'll use brackets. I want to index into C, and I want the 5. So to index into the 5 in C is going to be that I actually, so I want if we can see, I'm going to try to take this away. So here I have, it's on the second column and the first row. So if I open the bracket, row 1, so it's rows and columns. So row 1, second column, and it's going to give me that data. So if we run this section, it's going to give you D is equal to 5. But if I wanted everything on all the rows, so I want both 5 and 6, so I want everything on second column, I'll index into that by saying D is equal to C, so I'm indexing into the C variable, and I want everything on the second column. So I'm going to say I want all the rows. If you want all the rows or columns when indexing, you use your colon symbols. So if you put the column symbol, it means I want all the rows. You say comma, and I want second column. So if I check that, it would give me, and you run that section, it's going to give you D is equal to 5 again. Now, D is 5 and 6, sorry. Now it's telling me something here. So when you have this line, it's giving you a warning. The value assigned to variable D might be unused. So it's just giving, that's a warning that I can ignore because I know that I'm the one that assigned it anyway. So that's fine. So this, another advantage of your live editor or live script is that it gives you warnings to see if you need to make any change. If you know that you don't need that change, you can ignore the warning. If it's yellow, it's a warning. If it's red, it's telling there's something wrong with your code that when you're going to run, it may not be able to run. Or when you run, it gives you a red and you're not able to run it. And that's also something that you need to check as well. So moving on, we've been able to index. Now, if I want to index and get 2 or 3 rows or columns, what I will do is I want to get 2 columns for all of the rows. So again, to index into that, if I say C, now I want all the rows again, so I use my colon symbol. Now I want 2 columns, so I want the column 2 and 3. I'll say from column 2, I'll use colon again to 3. So I'm saying from, this is the second, after the bracket, after the comma sign is columns, right? And instead I'm telling that take the values from columns 2 to 3. So take everything in columns 2 and 3. So I should have 5, 6, 8, 9 come up in my solution. So if we do the section, run that section, we check, we now have 5, 6, 8, 9. Is there any questions so far?
Which exercise folder or file are we currently?
So we're not working with any exercise folder or file right now. So this is just the basics. So there's no exercise folder for this. This is just showing you how to do certain things.
Okay. How do we actually run the code? Let's say, for instance, now we already have our editor opened through the new editor, through the new script, if I'm correct.
Yes.
And after doing that, so someone types A is equal to, in braces, like writing an array of 2, 5, 6. And
okay.
how we can run that now?
Hold on. I just need to quickly move away from this, okay? So was everyone able to see my screen? So this is what I said is that you can use run to run it. So if I delete everything that we've been doing, so I'm starting over. So we want to start this. So if you want to write a new script, basically, we can do it here actually. So you want to start over and say, okay, I'm going to start with A is equal to, I'll call that 3 plus 5, but I'm not going to run anything yet. So I'm going to use my semicolon. And then I'm going to assign my matrices. I've got 3, 4, 6 for the first one. For my row vector, for my column vector, I've got 4, 5, 7. So you have everything. So you're writing your scripts this way. So you're writing a script right now, a programming script, where you're telling you everything you want, the code you want to run on each line. So you're going to do all of this at once. So it helps you to automate. So I've done all of that, and I want to run this code now. I'm going to go here. So you can see here it says run, and here it says section. So this one is very simple. I can just use run to run it. So once I do that, it runs everything. Because I put my semicolon, doesn't show me the output here. It just saves them straight away. So if I check A is 3 plus 5, which is 8. So we've got A is 8 in your workspace, in your workspace window. If I check B, I've got 3 forces in my workspace, and if I check C, I have 4, 5, 7. So it's running it efficiently. If there was a mistake in here, let's say I say D and I put is equal to, but I didn't say anything. It's going to give me an error. You can see here, it said error found, claim to go to next message. So it's already telling you that there's an error. But if you did not notice that error, if you run it, it's going to give you an error when you run it. So it says this statement is incomplete. Can you see? So because of this, I'm not able to run this code. So it's not going to run. because of this is incomplete, so it does not complete the run. So it started with A, B, and C. It would have given you your A, B, and C answers, as you can see, but there's nothing for D because you did not complete it. So it's giving you an error. Now, run is good if you're running everything at once, but what is usually helpful in a live situation is the section. Because with section, it means that you can section your code and it helps you to find out if something is wrong. So if I'm trying to find out what's wrong with my script, I've written a long script, I can then put it into sections. So here now I know that this thing is incomplete. So if I go to C and I say here, I can click section break. If I click section break, now it tells me that I've got to section. So if I come back here and I run this as a section, here, so I'll say run section. My cursor is here, so it's only going to run the first and 2 program lines. So run this section. So it's going to run and there won't be any error message. Then here it says this is I know that this is going to be the problem. So one of that thing I can do here is now I want to see what the problem is. So I can comment out this D. So we use this to comment out. When you turn in something into a comment, if you work on Python, you will know what that is. If I comment it out, it means that the MATLAB, the software is not going to run that code line. So I'll now go back to say run this section. It's going to see. So you can run it without giving me error message because I have commented this out. It's going to ignore that part and only run the C is equal to this. So it's running section helps for you to work in stages, see if you're getting it right, and then if you have issues wrong with your code, you can identify where the problem is and change it. Does that answer that question?
Yes, it does. And the observation that I've made is the fact that it's like there are many scripts and one has to just know the exact one that one needs to use. Because if you go to the home page, so what differentiates the M script from the .mlx, you know, there's a live editor, there's scripts, there is all those things seems confusing. If you can shed light on that, thanks.
Okay, so what I said that I showed at the beginning when I tried to use a .m. So everyone, we use the live editor, so the live script .mlx, because it means that when I'm running this .mlx, I'm able to run it without saving this name. So it's given as untitled, and I don't have to save it. And it's also a way for me to be able to see if I made a mistake. If I open a .m script, so when you say scripts, that's not a live script, that's a .m file. So this is a .m file. It's looking different already because the output are not going to be shown on the right, unlike with this one, where you have this icon because this tells you the output as you go ahead. So here I also do the same thing again. A is equal to 3 plus 5, just doing the same thing to keep it simple. I've got my matrix 3, 4, 6. I have C is 4, 5, 7. So now, when I did this here, it said untitled 2. I didn't have to save it to run it, right? If I try to run this here, so something else you can see here is that I don't have the option of text in this .m script. So it's not live, it's called editor, it's not called live editor. So it's just a normal script. You're not able to do a lot of things with it. I can't say I want to plot in here. If I go to my live script, you can see that what I have up here is different. I have access to text. I can, put controls in my code. I can give it some tasks to do. I can ask it to create some plots based on the data I've got. So I have a lot of things. So we can do a lot more with the live script than we can do with the .m script. So it's just a basic script. And also, before I can run this basic script, I can section the basic script if I want, but it's not, you don't get the whole section the way we have it there. You have to be the one to create your section. So to create your section, you will use double comments. Now I have a new section with the .m script. Whereas in the live script, you have, you can even click section break and it does create the section for you automatically. You can see. Then the final thing about the .m script, which is the normal script, is that before I can run it, I have to save it. So when I say I want to, it asks me to save. So I'll say basic. When I run now, I've said and I can now have been able to run and it's run it now. And when you run it, you can see the answers are still here. So you can, if you look into your command line, it's now showing you that you've run the script basic. Okay.
Thank you. And if you go back to the .mlx, that's the untitled 2. Okay, if someone includes another variable C to be number 3 inside the first script before the section, okay, will it project the result for all the variables? Or okay, it projects result for A because A is a calculation, but for B and C, it only store their values in a storage. So the output will just be 8, no other value.
So here you will see, the output will be what you've stored in it. So A, I've stored 8 in it because it's a calculation. B, I've stored this matrix in it. So I'm going to remove this for you to see the outputs. I'll remove the semicolon signs. Now, if one thing is with MATLAB, it overrides quickly. So I've called this C457. If I now come down here and I do another C, and I call that one, the first C that is 457, and I say I want to add 7 to that matrix, it's going to add 7 to all of the individual data, right? It would first do the first C, then the second C would give you a new value, so you would not see this one anymore. So on your workspace variable, it's going to save the last C that it was given, but on your output, you will see as it goes step by step. So if we run the old thing, now, because I've still got this incomplete line, is giving me that an issue. So let's run it again. So you can now say that when I have the whole thing now, can you say that A is 8 because A is a calculation, 3 plus 5. B is just a 1 by 3 matrix, so 1 row, 3 columns, and has the variables 3, 4, and 6 that I've saved into that. C is 4, 5, 7 because the first C is a column vector. It has 3 rows and 1 column, 4, 5, and 7. The second C is this C plus 7. So it's going to add 7 to the individual numbers in the first C. So you can now see that it's 4 plus 7 is 11, 5 plus 7 is 12, 7 plus 7 is 14. So if you now come to your workspace window, the C that you're going to see, to view what's in your workspace, to view the data, if you double click like this, it shows it here. It's your 11, 12, 14. So it's overriding the previous C. So if you want to keep both of them, you have to be careful with how you name your variables. So if we had called this D, then we can keep both values. Because now, if we run it, we will now see that we have A, B, C, and D. So we have access to everything. Is that clear?
Very clear, thank you.
Okay. So unless there are more questions, I'm going to stop there. We can take a mini break because we're meant to start the second, so we can take like a 5 minutes break. And then by 1:15, we'll start the first interactive session. So if everyone opens the visualization script, not the workspace. So the visualization script is what we're going to be working with. So the one that is called data visualization.mlx is what we're going to start with in about 5 minutes. So this one here. Okay.
Okay. Now that we are on break, if you have technical issues or you have any concern, you can always notify us. I will run a very short poll now so that in case to just be able to know that you are on page and that you are happy with what is going on. Okay, so if you have any concern, if you need to share your system, you can do that. So we support you so that you won't be lost when we get to the next session. I'm so happy now that Monica already has our audio. So Monica, have you been able to get that system up? Hello, Monica.
Yes, hello, sir. I'm on the system. So
Okay.
I went to my email.
Yes.
And I said I saw a MATLAB workshop, join the class. I joined the class.
Good.
But I'm getting something. I'm not in the
Have you
Zoom.
installed the MATLAB now on your computer?
No, I'm not yet. I'm not
Okay.
yet until I go to the Zoom. If I go to Zoom, it's telling me I should provide
Okay.
what do you call it? The meeting ID.
Okay. What will happen is like if you can go to your browser and type MATLAB trial. You know, so you open a browser on your computer and browse MATLAB trial. Then you click on the first one that shows up so that you'll be able to install the MATLAB.
Okay.
Once you are
MATLAB
done with that,
trial version.
yes, exactly. So once you are done with that, then we will be able to give you the link to download the folder so that you follow what is going on.
Okay, so I saw MATLAB MathWorks, but not trial version.
Okay, share your
screen. Download. Maybe I should put download.
Do you mind sharing your screen?
Okay, let me. So that's what I'm.
Do you mind sharing?
What I'm saying is that.
Yes.
Yes, I would love to share my screen.
So that we can see and follow it. Okay.
Yeah, but I can't access the Zoom platform on the computer yet.
Oh, you can't. Why?
Still
because you
using
need to
my phone.
register. Okay.
Yeah, you see, I have to go to. Okay, so I have to register. You see, sign in.
Yeah, do that one first. When you are done, notify us. Yeah.
Okay, sir. Okay, I will do that now. Then I will let you know through chat.
Okay. Unamdi, how is it going at your hand? Hello, Unamdi.
Hi, good morning.
How is it going at your end?
Everything is going on well. I'm just about to import the folder I just downloaded from the link.
Do you mind showing us, sharing your screen and showing us some things you have done to follow at least a little bit? Just show us what you have done from what she has said now.
That's no problem.
Okay, so share your screen and then open a script. Oh, you have done that, yes. So what are the new discovery that you have made from the explanations? And you can just, maybe some of us, we also learn from you during this break to see how you have absorbed some of the lesson past.
Okay, I'll just close this one now. No, don't save, just close. Okay, so so far, I got to know that I've got to know the difference between a live script and just a new script, because I didn't really know the difference before now. So I now know that I could create this from here and all my codes will be in here.
Okay.
And basically, if I need MATLAB to not output my code, if I need just the output of the code I'm writing, basically, I need to put a semicolon to do that. And I got to also understand the concepts behind the matrix format.
Yes.
Yeah, so I got to know that. Also, I got to understand the of course, the difference between the matrix formats and then the what's it called? Indexing.
Okay.
Yeah, the indexing part of it. Give me a minute to see if I could come up with something. Okay, so you see, it's indexing but it's still a little bit confusing though.
The indexing, right?
Yes.
I think
okay, there's no day.
When the professor comes on break, we'll be able to raise that question. If you can raise that question.
Yeah, it's still a bit confusing.
Have you downloaded the folder? Oh, you have the folder for the workshop.
Yeah, I do. Yeah, I was about importing it.
Oh, you can just click on that arrow in front of the downloads.
On the folder, on
the arrow in front of the downloads. There's an arrow in front of the download. There's a short arrow, inverted arrow pointing.
Oh, okay,
that,
yeah.
Yes, and then PKRN workshop folder. No, it's up. You just jump it past. Yeah, so you can just click on ARN. That makes it faster, and
yeah,
I think it loads faster. Yeah. Thank you very much. Okay.
All right. Thank you.
So you can raise that question to Khadijat when she comes back. On
All
that
right, we'll do. All right. Thank you.
You're welcome. So we have Patrick Kabuya. Patrick, hi, Patrick.
Hello, sir.
You're welcome. Where are you joining us from?
Okay, the B is coming before.
Where are you joining us?
I'm from Congo, currently in Cyprus.
Wow, we're happy to have you from Congo. And it's interesting because, you know, we should be speaking in French, but yes, you understand, you are bilingual, so you understand English and French. You know?
Yes, I do speak a little bit English.
Oh, just un peu, like.
Yeah, oh, yeah, un peu.
That's interesting. And I think we have always been having that issue with our Francophone members because we were required that they should have bilingual. But one of our director, Mukile Kasongo, he speaks about French and English and all this. So sometimes when we have sessions, we always make provisions. If we're aware that we're going to have one or two persons, then it will just be throwing transcription in French. But in the meantime, we just put transcript so that even if the instructor is speaking fast, you can always read that. And so do you have your system open? You have the MATLAB installed?
I was struggling. I'm actually struggling to download the MATLAB. So okay. I'm actually a little bit behind.
Okay, that's why we are having this break, to just be able to have you to catch up. You know, the MATLAB, somebody raised a concern, maybe location, but I think it's because it requires 4 gigabytes and the memory it requires, it may not work on a mobile phone. So what I will advise is if you have your laptop on now, you know, and you are using your laptop, we can assist you if you share your screen.
Oh, I'm what? I'm on my phone?
No, you're on your phone or your laptop. Are you using laptop or phone?
I'm using my phone.
Okay. Can you also use your laptop?
Oh, let me turn it on.
Okay. So you turn your laptop on and you join us through your laptop. You can also join us on Zoom through your laptop. That will help us to see what is going on your laptop and give you support so that you'll be able to follow. Yes. So you see the way Patrick just show his laptop and we're able to, the same thing Monica is setting up our laptop to be able to join us. The software cannot run on the phone. Yes. So when your laptop is on, even if the Khadijat continues with the session, we can always, like after the whatever, once we have a longer break, we can always look at what you have done. Yeah. And if you want to reach out to me once Khadijat starts, you can drop that in the chat.
Oh,
yeah, merci beaucoup. Chineye, sorry, I'm calling people out. This is just to be able to give you one-on-one support. We are few and we have to ensure that you make the best out of your time. So Chineye, we don't know now your audio is connected. And
so yeah, it's connected.
Is your laptop connected now, Chineye?
No, mine is not actually available at the moment.
Okay.
So I'm using my phone. And I was even on the chat platform to ask if provision could be made could be made later for people who don't have their laptop available, maybe for assistance.
Okay. The assistance we can give for those who don't have laptop is we are recording the event, okay?
Okay.
And as we are recording it, you can watch it later and practice with your laptop. But I will advise you, if you have a notebook, you can jot down some salient points, and look at the areas you understand and the areas you don't understand, so that you can be able to ask questions. We also have a Google Classroom. Are you on the Google Classroom?
Yeah, I tried opening it and it was asking me for I should request for the class code. Because I tried running it with
so we give you the class code now, so that we'll continue. That will also help us to, after this workshop, to be able to meet up with things you have jotted down, the areas that you are confused. You can always reach any of the two instructors, either the facilitator or the moderator, and then myself for support. Thank you very much. So if you have any other concern, but I will advise you, but the best way to follow is to have, like, if I don't have my computer on, I have a notebook. I'll be sketching some things down, and then ensure you ask questions. Things you don't understand, stop the instructor, ask questions, and make the bed. And then so I will drop the code in the chat too.
Okay, thank you very much.
You're welcome.
Thank you very much, Dr. Austin. You are already 10 minutes.
Oh, sorry, sir. I'm muted now. I'm out.
Yeah. So over to you, Dr. Khadijat.
Okay, I was muted. So thank you. So welcome back. We're going to share our screen again, and we're going to start from the first one that I called data visualization. So there are two files. There's one with solution, one without the solution. So we're going to work with the one without the solution. So we're going to work and follow along together. Let me just share the screen so you can see what I'm talking about. So this is the one that we should have open now, data visualization.mlx. So it's a live script, and it's a live script, and we can see that it's going to allow us to work with some of the things that we're going to learn, the ones I've talked about, and we learned some new things here. So we're going to work together. So as I'm going, try and follow along as you can. So if you open your MATLAB, open the file. So when you open the MATLAB, make sure, like I said, the folder that you've saved this in, you double click it to add it to path, then you'll be able to open this, click in this live script here that I've already saved. So next about the data we're going to be using is this data here, the one in the Excel file. And then you'll see how, so the first thing I said is that we want to start by looking at using line charts to visualize data. So you can use it to visualize data in different formats, both in 2D and 3D. For today's purpose, we're going to do everything in 2D. For anyone that wants to do more, obviously you can then do further research yourself and to be able to learn to use it for more things as you go along. But just the basics to get you started. So first, line charts, so line graphs basically, which can be used to show trends over time. We're going to import the temperature and quotes sold data from our data file using the import tool. So I think I forgot to show you that initially. So if you go back to your home tab, you have here this file, this tool here that says import data. So if you click this import data, is a down arrow that is green, it's called import data in the variable section. So click import data. So when I click import data, it's going to open the current folder I'm working from, and I'll click data I want to open. This is the Excel file I want to import from. So if I open that, so I already have it open here. So I've got it open here. So when you open the Excel form, you can see the sheets that you've got down here. So we want the temperature data. So it's this one here. That's temperature data. Now I want to first import the temperature and quotes, number of quotes sold data. So here it's got everything I like. So if I come back here.
Sorry, Dr.
Yes.
Khadijat. We have a francophone person here. And if you go at a slower pace, it will really help. Thank you.
Okay,
please.
okay.
Yes.
So we want to use the temperature and quotes sold data sets. To do that, this is highlighting the full data. We don't want that. So we can click, hold, and drag like this up to down here. So the temperature in degrees centigrade is 2 the number of coats sold when the temperature is 2 degrees is 50 coats sold. So I want to import this. So now I can import this individually. I don't want it to be together as a table. So I come up here to the output type. If it's a table, it's going to import it as a table, but I don't want it to be a table. So I'm going to say I want it to be column vectors. If it's the numeric matrix, they'll come together again. So it's going to be a matrix that has 2 columns and certain number of rows. But I want them to be the 2 different variables individually. So I'll say column vectors. So when I say column vectors, now it tells you the name. So this is the range. It's going from E2 to F11. So this is E, column E2 all the way to F11 down here. So that's the data set I want. Then the variable names row. So where should it take the name from? It's taking the name from the first row, temperature and coats sold. So if I click this to see, so it's getting temperature. Don't know why it's doing this. So yeah, okay. Okay. So temperature, I want to change the name from this. If I double click here, then I click again. I don't want the C1, so I can remove the C1, but I'll leave it there because I've already got it like that in the other one actually. So leave it as temperature C1. So once again, just do it again. So you click, you hold, you drag to highlight the old file you want, call it column vectors. This is the variable names row. Then here we say replace unimportable cells with not a number. So what I actually do is I exclude rows with unimportable cells. So anything that is not importable is not. So because we have everything, it's not going to do that. If I had actually done this like this, just to show you, now this is the unimportable cells. So it's not going, they are non-numeric cells, and I've gone for column vectors where everything has to be numbers. So it's not going to import these 2 rows. But since I've already actually just highlighted the one I wanted, there isn't anything for you to exclude, but it's good to make sure you say that exclude rows with unimportable cells, and it's not going to import them. So you now click this tick button to import the selection. Then it tells the temperature C1 and code sold has been imported. So if you go back to your MATLAB workspace, now in your workspace window, you now have temperature C1 and number of coats sold. So here for us to then do it, for us to then draw the file, we're going to say X, we're going to create a variable called X is temperature C1 and Y is coats sold. So we've just used that because of when you want to use the plot, you don't want to type in temperature and coats. So you can then say plot X and Y, X, Y. So remember we're plotting a line graph near the X-axis and the Y-axis. So X-axis is our temperature, Y-axis is our X-axis is our temperature, the Y-axis is our number of coats sold. So we call it plot X, Y. So you type plot X, Y. I've already done that for you. You give it a title. So for title, you write title, open brackets. Then you always have to use this apostrophe sign, quotation sign, to say that you want this to say temperature versus coats sold. Then here is to give it the size of the font. So it is not compulsory, it's an option. So if you just use temperature versus coats sold, MATLAB would use a default value for everything. But if you want to give a particular size, you want the font size to be 12 or 14 or 8 or 10, you say font size, 12. So first I'm going to actually take it here and comment that section away. So MATLAB is going to just give it a normal one, the temperature, and then this is all I use to write the degree centigrade, the number of coats sold. So if we run this first section, so I've sectioned it out to be this ozone section here. So if I run, so now here I'm going to go to live editor. I'll run this section. If everyone wants that section, having imported the data, you should get a graph that looks like this. So we can see that as the temperature increases, we're selling less and less coats. Is that clear for everyone? Can I get people say yes, no, please, so I know that we're following along.
I think it's clear for me, but if you can still have a kind of a recap of the steps. That is step number 1, you know, you get your data. Step number 2, this is where you import. Step number 3, this is where you just those steps you can make it. It's really be helpful. Thank you.
Okay. Yeah, so we'll do an exercise now to use the steps that I've just shown you. So we now want to do the same thing using the month and temperature data sets and plot the temperature data only and label our axes like we did here. So here we imported the temperature and quotes number of quotes sold data. So now to do this, we're going to import the data again. So we go back, so we don't have to click the import button anymore because we still have it open here. So you go back here. Now I want this column B data set. I'm not going to import the months because it's going to, I won't be able to actually label the month, January, February in the graph, in the line chart, but I will just import the temperature data set. So I know that month January is 1, February is 2, March is 3. So if I import this data like this, so you can see is a column vector. So the name is going to be temperature here. And then I'm excluding the rows with unimportable cells. So if I click import, I've got that data. So it's got temperature C given to me. So if I go back to MATLAB now, in my workspace, I've got temperature C, and it's called a 12 times 1 double. So it's just saying that there are 12 rows and 1 column of data in it. So I want to then plot that now. So all I'm going to have to do is here I use plot x comma y because my x-axis has specific values. If your x-axis is just going to be numbers starting from 1 to 12 or 1 to 14, you can ignore the x-axis when you're writing your code for plotting. So we take out the comment sign. So we say plot temperature. So I want to plot y, so temperature C1. So when you plot T, it's going to give you int based on what's on your workspace. So instead of typing the full thing, you can just do this. So temperature C is what we want to plot, not temperature C1. Then we want to give it a title again like before. So I'll type in title, use my quotation sign, and say temperature per month. Now I'm going to actually give it a font size. I'll say I want it to be font size. So you can give it different value pairs. So it can be background color, button down function, but we're using fonts. So I say font size. So you can scroll down again. Font size, I want to give it 14. It's going to be font size of 14. Then I want to give my X's label. So I'll say X label is month in number. Or we actually ignore X label in this case because we don't have any X specific access. So we use Y label only. We say Y label is temperature. You have to remember that if we don't use this, it's not going to type it for us. So to type our text, we always have to make sure we put our quotation sign. So now we can plot this new line. So if I run section, I'm going to run this first part and this part again because this is part of the same section. So we're going to rerun this and it's going to run the second half as well. So now we're going to have 2 graphs on the right, if everyone can see. So you have your temperature versus cost sold graph and you have your temperature per month graph. So the good thing is if I now want to do more things with this graph, just before I go ahead, so if I click this graph here, there's an arrow on the right hand of the top right corner of the graph, and it says open in figure window. So if I click the arrow, it opens the graph for me in this way for MATLAB figure window. So here you can do more with it. You can make it bigger, make it smaller. You can add other things, and then you can save it as a MATLAB figure. So if I want to edit, you go to the Edit tab, and then you can say that you want to edit the figure properties, for example. So when you click this, it has a property inspector that opens on the right corner. and it has different things. Your menu bar is figure, your toolbar is the automatic, the position. So you can change anything you want to change. The plotting, if you want to change this, you can. We won't be doing that, but we can also look into the printing and expecting. So here we won't actually have anything to change here. So instead of this, we can then go back and change it to, instead of figure properties, you can also edit the axis properties. So if I use axis properties, so here we can change, so you can see I can change the font name for my axis. So instead of it being Helvetica, we can change the font. So we can work interactively here and change it to Arial Black, for example. You can see all the font names have changed. You can change the sizes. So they're all size 10. I can make them all size 12. Now they're all in size 12. I can bold it or I can unbold it. So this is how, so MATLAB is good for working interactively. So you can do all of this. You could have done all of this as well when you're writing the code to plot the graph. But if you didn't want to do it that way, you can also do it like this by changing everything. Then you have your X tick. So your X tick is what number do you want to write in your X axis? So you're saying 0 is 0.5, so you can decide to change it. And so automatically it gives you this MATLAB itself. So you can choose to change it from to be 0, 1, 2, 3 if you want. So you can decide to change it like this and delete some of the ones you don't want if you want, or you keep it like that. It's up to you. So you can work on all of that. So you can add grids. So here we have grid. I can start to put an X grid or Y grid, so it looks more like a graph if you want, but you don't have to. So you can sort of edit and make changes to your plot by using this interactive inspector on the right. So you can change the position. You can decide to do a multiple plot and create another one if you have more than one plot. The labels, so axis labels can be edited here. We've got the title, we've got the label, so you can change them here if you want by going to the text, and then you can change it. So you've already written it here, then you can change what is written and edit it here and change it. Then you can change those individually and give them a different font, a different size if you want. So this is how you can work with it. And then you can save this figure on your computer by looking at your save as, or you can even generate the code that is used to draw this figure like this. Okay, so Augustine has raised his hand. What question do you have?
Sorry, hope I'm not disturbing the class. I raised the hand because I got unrecognized function of variable C1. And I think that should be because I've not been able to link my spreadsheet with the, that's the data from the training with the code. So I would like if you can shed light on how to connect that code. There are two panels. So we have the panel containing the data, how to connect them together, and how the variable temperature C1 is able to see that column. Thank you.
Okay, so what happened is I'm going to ask him, when you open the data visualization file, it first told the temperature C1 is unrecognizable. Was that it?
Yes, unrecognized function or variable.
Yes, because what happened probably is I think I ran it before saving it when I did not have the variable. So when you're running your script, what's going to happen is that when I'm writing this axis temperature C1 and I run it, if I have not saved a variable in my workspace called temperature C1, it's going to tell me unrecognized variable and it's not going to run. So that's the issue. So you have to import your data before you can run your scripts. So if you have things in the script, but you don't import the data first, then it's not going to work. And that's what happened essentially here, was that we haven't imported the data. So when we open the script, it tells you that because he opened it maybe thinking it's going to run, but it's not that it wants to run. It's because of how I saved it. When I saved it was after writing the script and working with it, I had run it without having a temperature C1. So it's saved as the last thing I did on it, which is with the unrecognizable variable. So it's not going to recognize it. So, but once you've got your data, so that's why the first step is, we see I wrote here, is you have to import the data first. So once you've got
How
the
do you
import
import it?
data, so I went through that by saying you go to the import tab. So you click this import data from file button. It's going to open your folder for you. So you click the data you want. So the Excel file is I want to import from here. And I say open. Then it opens this new tab for me where I have the data. Then I'm going to go to the data I want for the temperature. C1 data is here. So if I click this here, I've elected data I want. The output type is as a column vector. Then I'm going to exclude rows with unimportable cells. So when you say column vector, it's going to be numeric data. So anything that is not a number is going to be excluded. Then you say you want to import a selection. And it's going to give you this name here that is in bold font. Okay. Is that clear? Okay, I'm going to assume that is. I'm going to assume that is fine and move on because we're running out
if
of
you stay
time.
where you are, sorry, you have a very slow student. If you stay where you are now, on my own, beside unimportable, like when we have taken the option that exclude rows with unimportable cells, right?
Yes.
And then at that point we click on import. That
Yes.
is very clear. And if you can slow down to even myself, I'm not francophone, but you know, I'm not, some of us are not used to British English. I'm not very so if you can slow down to the way you just did this one, it will really be very helpful. Thank you.
Okay, so now when you now come back to your script, you will now see that on your workspace, temperature C1 as a variable has been imported. And you can now, the code sold has also been imported. So you can now come back to the program where you said X is temperature C1. So I'm assigning the data in temperature C1, I'm assigning them to the variable X. The data in the code sold, am I assigning it to variable Y. So I'm creating a new variable called X and Y. It has the same data as code sold and temperature C1, but I'm simply doing that because I want to be able to automate my programming. So I want to plot X and Y. Why I'm doing that is that if, say, I had another set of data, I can simply change this and this, and I don't have to change my plot X and Y. So I can keep plotting X and Y. I'll just change what I assign to X, what I assign to Y, basically. So when I now say for the exercise, so this is the first one. Then to now see how it works is we now want to do another one where we are importing the month and temperature data set. We want to plot the temperature only. So going back to the import output here, the months and temperature data set is A and B, columns A and B. So we want this column only. If you click the top of it, it highlights a full column for you. And then if you say column vectors, exclude rows with unimportable cells, the purple one is not going to be imported. It tells you the variable names rule. So the name for this variable would be temperature, which is what's in the bold here. It's on the first row. So it's going to take this as the name of the variable temperature. If you want to edit that, you double click. Then you can edit it, or you click again, then you can delete or whatever. But I'm going to keep it as it is. And then once you click your import again, it tells you temperature C has been imported. It has 12 rows and 1 column. You minimize that and back to MATLAB. You can see temperature C now has been imported. So now I can run this program where I say plot temperature C. I'm saying plot temperature C because I know that the X is in continuous order. 0 is from 1, 2, 3, 4, 5, 6. Since I don't have here, I had to give it an X value because I have specific X values. Here, I don't have specific X values for my X axis. So it's going to be default. That's just going to give it 1, 2, 3, 4. I don't mind because it's just continuous. It's monthly, so it's 12 months. And then it's just going to plot this temperature on the Y axis. So that's the plot we have here. Okay. It's going to plot temperature on the Y-axis, and I've given it a name. The title is temperature per month. The size for that title is 14. Then the Y label is temperature. And you can see that the temperature here is a different font size than this because I specified the font size for this. I did not specify for this. It's going to use the default one that MATLAB uses to write. Is about 12 or 10, I believe. So just like we did for that other figure, we can also open this by clicking on it, open it in the figure window so that we can then do more things we want with it. I'm going to close it first. So I'm going to also introduce something because we can see here, MATLAB just went from the lowest value to the highest value of 16. So when we got here, is just like, you know, is closing with the axis. So I can actually say I want to give the values that I want for this graph. So when I say plot, under plot, you can also introduce something called your Y limit value. So the values for the Y-axis, we call it Y lim. So when you type Y lim, is your set or query your Y-axis limits. So open a bracket, then I'll use my square bracket. I want it to go from 0. I want it to go from 0 to 18, for example. So you write 0 space 18, you close your square brackets and use. Then I want to change my X limits for the axis as well. I want that to go from 1, or I can say I want that to go from 0 again to 14, just for me to see the graph clearly. Then we're going to run that section again so that the changes we've made to our code is going to be implemented. So now we've run it again, and then we've seen the changes made to our code, and it's now being implemented. So I can then open this figure in figure window. So if I open it now, you can see it clearly that it starts from here. At the first month, the temperature was 2 degrees. The second month is also 2 degrees, but by the third month, it's gone up the fourth month. So you can see how the positions, so 3, 5, is indeed notches are where it happens. So here is the same, and then it starts coming back down again. And then you can save your figure by going to your file, use the save as, and then decide on where you want to give it a name, line temperature per month. So when you're saving things in MATLAB, you don't want to give space, but you can use underscore. So temp per month. So it's going to save as a MATLAB figure. If you want it to be a figure that you can open with other files, so you come back to your save as. So you now use a save as type. So I've saved it as MATLAB figure. So this one I can only open on MATLAB. If I want to open a different type of format, I can now come here and check. You can use bitmap if you use that. You can use EPS, but the common one is you can either use PNG or JPEG, because you can open those ones in a lot of different places. So if I use JPEG now, I'm going to save as JPEG. Give it the same name, say save. So if you now go and check on the right, on the left-hand side, your current folder, it's already there. So you have two files for that image. You've got temp_month.jpg, temp_month.fig. So if you open the temp_month.jpg, it's not going to open because it's on MATLAB. But if you go to your computer workspace, you can open it. So you can see it here what it looks like, but it's not going to open on MATLAB. So you can open it from your computer workspace and from your main computer explorer later. But you can open the MATLAB one here easily from MATLAB. It should open. It's already opened anyway here. So moving on to the next one. I think that is clear for everyone now. The next one is, okay. Augustine, yes?
Yes, when I tried to do the export, I got error using HG export, error using HG convert unit. The first input argument must be a figure handle.
What were you trying to export? Sorry. So
you gave us the direction that we should open, we should open the, what we call it, the chart. We should open it in the figure window. And in the figure window, we should go to save as, right? And in the save as, we can give it a name and take a JPEG version for it.
Yes.
So that's exactly what I did.
So what did you give it the name as?
I just save it as, I gave it the same 10 per month.
Did you use the underscores as well?
Okay, that's another thing. So let me just
because
save
I was
as
saying that you don't
now.
keep space. So if you use underscore.
Okay. So it works now. Thank you.
So apart from folder names, when you're saving things, so it's good to just clarify, apart from folder names and maybe things like my Excel data files, when you're saving in MATLAB, you don't want to put space in your titles for what you're saving. So you can use underscore, so you can write them all together, but you don't keep spaces. Okay, so moving on to bar charts. So we know bar charts are bars, basically, to compare different categories and groups. So what we're going to be using here is the favorite subject data. So first we need to import the male and female favorite subjects. So if I go back to the import data training that we already got open in our import section, if you come down here, you have your sheet name. So if you go to the one that says Year 5 school subject data and click that, you should have this open to you. Now this is showing a bunch of this because of what we already got selected, but we're going to change our selection just soon. That's why we've got all of this. So if you have this open to you, the first set of data we want to import is the one down here. So we have for the female, the favorite subjects, 7 of them said maths, 15 of them said English, and 10 of them said science. So this is a randomly generated data. And for male students, 14 said maths, 4 said English, and 12 said science is their favorite subject. So we want to import this information. So let's import the female first, and we're going to import the male as well. So I'll click on 7, 15, and 10 like this. Now I'm going to import this as a numerical matrix, not a column vector, because I want it to be one set of file. Then also I'm going to make sure I change the name here. So if we go to the program, I've already given it a name called female fave subject. So I'm going to name it female fave subject here. So I'm going to double click this, then name it, change the name, female fave subjects. Enter that, and now I'm going to import it. So I've already said replace. I'm going to go back to exclude rows on importable cells. Again, I'm using numeric matrix because I want it all to be one cell of data. I don't want it to be individually. So I'll import that. Then do the same thing for the male students. Highlight this 3 again, double click. Then I can also click to make it achieve faster. Male fave subjects. My output type is still the numeric matrix. I'll import that. So now I've got the 2 sets of data. And then we'll go back to MATLAB. Is everyone following along so far? So if we come back to MATLAB, we can see now that we have female fave subjects and male fave subjects. Okay. So moving on to draw our data, our bar chart, we need to first define what's going to be the
Sorry,
under
Prof.
bar.
Sorry, Prof.
Okay.
The point at which you said double click after we have highlighted, so that we can be able to, where do we double click? We double click the cells, or we double click the.
So you double click the output variable name here. Can you see?
Output variable name.
So what happens is, because I said that, so here, let me just explain. So when I highlighted these 3 sets of data, 7, 15, and 10,
okay,
I go to output type. If I say column vectors, it's going to look like this. And it's going to give this variable these names here. It's going to give this one female. It will give this one variable name 10. It's going to give them variable name 11. because variable names row is row 1. So it means that it is extracting the variable names from first row. So the first row here says female. This one says nothing. So MATLAB just give it a name and it's called variable name 10 because it's counting from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the 10th variable in this file. But because I changed the output type from a column vector, because I don't want it to be, if it's column vector, it's going to give me 3 different files, 3 different variables. I want one variable. So I say I want it to be a numeric matrix. So when I say a numeric matrix, it's going to be one variable that is going to have 1 row and 3 columns in that matrix. Now, when I said one numeric matrix, the name for that variable is now going to be what is here. So because I've highlighted the female student's data, I will double click this to change the name. When I double click it, it gives it a blue highlight with the cursor. If I start typing, it deletes. But because I don't want it to delete the whole thing, I'll click one more time. Then I can actually edit it and delete. So I'll delete the capital M, right? Capital F-E-M. So now I've got female fav subjects. So now that's going to be the name for my variable. When I import that, it's going to import this variable called female fav subject and assign these 3 values to it. Is that clear now?
Thank you very much.
Good. So the same thing is done for the male values, which is here, 14, 4, and 12. You highlight it again. Make sure you've got numeric matrix as your output type. Edit the title by deleting the turning into male fav subjects. Enter, then import the selection. Now, because we are working with small data sets, we are going to be able to use import tool this way to import our data. But people that are going to be working, that might need to work with a larger data sets later on, if you click on this down arrow here, you can actually generate a script that you can use to import data. So you can generate a script that tells the program to use to import the data. So you can generate a live script. So I click generate a live script. It's going to give me a new script here called import data from spreadsheets. So this is the script. It's going to be, this is the workbook and the worksheet I'm using. So MATLAB has generated. So you can then use this, if you understand program, you can use this to work through and see how it does it and say, okay, it gives you an option. The number of variables I want is 3. The sheet I wanted from is this. The data range I want is this. The column names are these variables. The variable types are this. Then if I import it, I'm going to omit row. If there's any missing, will I omit? If there's any error, I omit. Then I state the variable that I want to option. So you have this. Then it's going to import the data from this table here called read table. Then it converts it to the type of data you said you wanted. We wanted a numeric matrix. So it turns it from a table to an array. And then it just clears the initial options. And then you have the temporary variables that were created, they have been cleared. And now you have your new data. So with this, what this is good for is that if you have lots of Excel sheets to import from or different one, you can just keep changing this name here. So you can change this from data for training. If you know that the data is in the same place, you just edit where it is to import, and then you keep all of this the same. For example, now you can import from lots of different data sets. So this is for if you have lots of importing to do, data to import, and you don't want to have to be clicking the import icon every time to do that. So you export the script itself, edit the script, and automatically import your data as many times as you want. This is just something to show for in case anyone is interested. So just to know that it's good to be able to read the script and it tells you how it was done. But for shorts, for small data sets, you can always use the import tool the way I'm using it now, because it makes it easier and faster for you. So I'm going to save that. So now that I've got our data imported, we want to draw our bar chart. So first I'm going to create a variable called subjects, because I want to be able to give it a name, the different categories. I'm giving it math, English, and science. Now, because I know that my data is 3 columns, 7, 15, and 10, they were math, English, and science, I have to make sure my title for the data is the same thing. If I've written math, science, and English, it's going to mean that it's going to assign math to 7, science to some 15, but it's meant to be math, English, and science. So make sure your titles for your labels is going to be the way the data is. It matches the data you've collected. So it's math, English, and science. Then this is going to be a cell. I want it to be categorical. So that's something with MATLAB is sometimes when we have text data to work with, it can be cells, it can be string, it can be categorical. So with bar chart, it has to be a categorical data. So you call it categorical. So you change it to categorical. So you say subject is categorical from the initial subject cell I created. Then we now have bar subjects. So to see that, what I'm going to do is I am going to comment all of this so I can run this initial part first for you to see. I'll comment all of this as well. So when I run this and I create subjects called this, I'll run this section. There's something called subjects. So you can see here, this curly bracket means that it's a cell. Now I'm going to use the next line turn into a category. So if I run this section again by uncommenting the next line, now is now categorical. You can see the icon has changed, it's now categorical. So now I can use it with my data. And now I'm going to do my bar charts for the first one. So I'm going to uncomment to use this here, or you delete the percentage sign. So now I'm going to run this section. So this is why it's good to be able to do things with MATLAB live script. So you can see that I'm running it step by step by uncommenting out the steps I don't want. So I run this section. So now we can see the female students bar charts. Here is giving out the bars in alphabetical order. So it's now English, math, science. If you want to change that, you can add some stuff to the bar chart to make sure it's in the order you want it, but this is fine. We don't really care about the order. So it's English, maths, and science. So here we have English is 15 students, maths is 7 students. Like we said before, we said maths, English, and science. Science was 10 students for the females. So for the male, we do the same thing again. We write bar, then we assign the variables. So the labels are the subjects, they are the x-axis data. Then the values are the male fav subject is the variable we've created here. That's the actual values that we want to plot, and then it's going to plot it, and we're giving a title called male students. So you can also add something else and say label. You can give your Y label if you want to add more data and say call that one number of students. We can have X label, and we'll call that one favorite subjects. So I'm going to uncomment this. And now we can run this section, and we have both sets. So we have, so now the Y label and X label, it only comes for the male student because I added it to the male student bar chart code. I didn't add it. If I want it to be in this one as well, I can copy and paste and add it to it. So copy and paste, Control C, Control V. So I had it to this. So then when I plot this one as well, I run that section again. Now I have my female students. It has favorite subject number of students. The male students favorite subject number of students. Any questions?
Thank you. It's very clear at my own end.
Okay. I hope participants, please, if you have questions, even if it's clear, we need to know that you're able to follow, please. If it's thumbs up or something, just note that, okay, you're following. Are they able to unmute as well if they want to, so they can say if it's okay or
Sure,
anything?
they can unmute themselves. You can call names. You can call people out. They can unmute. They can share screen. They have all the functionalities.
Okay, thank you. So what I'm going to do now is, for the sake of this exercise, I'm not going to show it to you. I want to make sure everyone can do it first. So you want to create a matrix now, because we now want to do what we call a group bar chart. You want to group this and this together into one bar chart. So I've started it off already for you. Then you're going to finish it off yourself. So the first thing is to create a matrix for all the students. To do that, I've written the code. If you call all underscore students and you give it the female and the male, that gives you a new matrix where all of them are together. Then, so now, you now need to write the barcode for the group bar chart, which is I've even written it actually here. So I've written the barcode already actually, so I've written it here, but what you need to write is bar subject, comma, all underscore students. And then if you run that, you should have a new chart that shows the two barcodes together, then include the legend. So include the legend. We will now just write a new one called legend. Open our brackets again, and then we give it name. So the first legend is female students, comma, male students. Now, before I run mine, can participants run theirs? And Augustine, if you can share your screen after you run it, so we can see the graph you create before I now run it on my end, because I know what it's meant to look like anyway.
So I think Nnamdi can share his screen.
Okay, Nnamdi, can you share your own screen after you've run it? Just for us to check. So should I need to stop sharing temporarily, right? So I've stopped sharing. If Nnamdi can share his screen after running it, so we see what the graph is meant to look like, then I'll do it on my hand as well.
Nnamdi?
So I think you're still working on it.
Okay, let me share mine then. I'm going to share now. Switching to the okay, let's give it a minute. Okay. Oh, can you see now?
We haven't seen your screen yet.
Oh.
It says I started screen sharing, but we can't see the screen. Now we can say yes.
So I think that's the part. So it's still writing unrecognized function or variable for the main scores.
So did you, let me see, mail scores. Oh, okay, did you run it as a section or you run the whole thing?
No, I just run, like we are all on this group bar chart where you actually create a
so but when you want to run it from the section tab. So if you go up, so don't click the run on the right. So you run section, yeah. So you're running it up there. That's why it's going to be telling you that. If you run it as a section, it wouldn't go down. Yeah.
I highlight. Oh, it's better now. Because I highlighted it like, oh, I highlighted it. So let's look at this again. The legend has been written. So I highlighted it, right click and say run session, right?
Yes. So you don't even have to right click. If you go up to the top, can you see run section is there? You don't have to be right clicking.
Yes, I can just click that run, right?
Yeah, so you don't have to highlight it. You just make sure your cursor is on that section, then you click run section. And then it just says, so it runs that section. I think you've already clicked run initially at some points before. So we're going to be showing you that. But once we get through that, it's going to. So now you can see, and it's giving you the legend as well. So that's what you expect to see. That the blue is for the female students, the orange is for the male students.
Okay. Thank you.
Thank you. So I hope that's also clear for everyone. So then we're going to move on to the next section.
You still want Nnamdi?
I mean,
do you still want Nnamdi?
No, if he's got something that looks like this, then it's fine. Just to make sure that someone else is getting it as well. So I'm going to assume everyone else that is working with us, following through, has something like this as the output they've gotten. If Nnamdi can just clarify if he's got something that looks like that, so we know that at least he's following. And I think Abel, so I know Monica does not have access to MATLAB for now, but anyone that has access to MATLAB, so Nnamdi, I think Abel has well said he was following, and Patrick. Okay, good. So Nnamdi has actually used it as well, so you even have the pie charts drawn somewhere. So Nnamdi, you've also been able to get it, so that's good. Okay, Nnamdi has gone further. He's done pie charts for them as well. So he's so we know that Nnamdi has a bit of MATLAB knowledge, which is good. Because he's already done the pie charts part, isn't the students. So let me see how you've used your pie charts, subjects and male fave subjects. But okay.
So no, I just tried to see if I change the bar to pi, if it was going to give me output of using the same code.
Yeah, so it gave you outputs, but then it's just giving you as okay. So it's only giving you as 1/3, 1/3, 1/3. So it's breaking down the English science. It's not actually giving the numbers inside. Yeah.
Yeah, I didn't. Yeah.
Okay. But that's the advantage of MATLAB. You can try things like that and see if it works or not. So you have an understanding of how it works. So we go to the next one now. So if you stop sharing, I can share my own screen again.
All right.
Thank you. Well done. So we're going to do box plot. So this is usually very good. The next section is box plot. So that's good for statistics, where you can look at distribution of data sets. So the exercise will be doing box plots as well. So it's be good if you pay particular attention to this section, because that's what we're going to be using to assess your understanding as the box plot part. So it's good for statistics because we can see how data spreads, the and show you back to our import section. So we want to use the favorite subject data set. So we are going to import to start with the male scores first. So the male scores is this one here on the right. Now I want to see, so now we have data showing what those students got from their math, English, and science exams. And we've already, so one thing I forgot to mention at the start is, when you collect your data, you need to make sure you've prepared your data in the way you want to use it. So initially, when we collected this data, it was just what you have here that was given to me that I had. So I needed to make sure I export and prepared the data the way I wanted to use them. I sorted it in the way I needed to use them. Did all of that in Excel before I started using it in MATLAB. So make sure that your data is in a format that you can put into MATLAB, so that if you need to sort it and prepare it, you do that. If you've collected with an Excel, do it in your Excel sheet or anywhere you've collected the data from, to prepare your data before you then move on to using your MATLAB for analyzing the data. So we want the male scores. So we're going to highlight again this 3 here, so up to here, basically. I've highlighted this data. Once again, I want it in a numeric matrix, not individual columns of data. So I want it in numeric matrix. I need to change my variable title, because if I do it as male fave subject, it's going to override the previous one we have on MATLAB. So I have to give it a new name. So the name I'm giving this one is meal scores. And then I'm excluding rows with unimportable cells just like before, and I'll click my import button and it tells me meal scores has been imported. So I'm going to do the female as well just to save time. While we're here, the same thing again. Highlight the scores that we want, the 3 sets of scores. We know it's the Maths, English, and Science score. So make sure you are aware of what is in which column, because it's going to be 3 columns. So we know the first column is your Maths, second is English, third is Science, and then I'm going to change the name here and call it female scores. So this is now female scores, and I'm going to import it. It's still a numeric matrix. I'll import it. Now I've got female score 16 times 3, so that's 16 rows and 3 columns imported. Back to MATLAB. The first one we want to draw is the box plot for male scores. Now, when you want to write the code, you write box plots, you open brackets, you put male scores. That's the figure you want to put in. And you can see that once you've written it, if you just put your cursor on it, because you have a variable in your workspace called male scores, MATLAB can give you a preview of what is going to show up there. So it tells you that, oh, I'm going to feed this data into this name that you've said male scores. And I'm going to give my box plot a label. The labels I want is Maths, English, and Science, because I know that the scores are Maths, English, and Science. So it's going to call each column of data will be called Maths, English, and Science. Then you basically just run that section. So you come up here to the tab, and you go to the section tab, you click run section. It's going to run it. You have your box plots. So if I open this here for us to see it bigger in the figure window, so we have our box plots. We can see here that there is a bigger range for the math scores for the males, because the lowest score is about 78, the highest score is 92, so the range is much higher than in English and Science. So a lot of the maths students did they did well in maths. You have a bigger range of data, and you also have a wider range. If you go to the English, the lowest score is 80, and the highest score is 92. So the range there is just 12. And if you go to Science, they all did relatively well in Science. So the lowest score was like 80 something, 84. The highest is around 91 or 92. So that means that's them. So if you click on it, actually, if you see here, you have information as well given to you. Group is Science, maximum is 92, minimum is 84. There are no finite outliers. So it gives you some information basically. And the red line is your median value. So it gives you the median value in that set of data is that the middle. They have, so median value sometimes is not really the mean, but it's related to the mean. The median value is 85. In English, the median value is also 85, but in Science, the median value is 90. So that's based on, we have 15 points and the middle value is 15. So you can see, and then we call this here the lower interquartile range, 25th percentile, and the upper interquartile range. So that means that here, 1/4 of the students or less got the score, and here 3/4 of students or more got the score. And then you can see here, so the scores in the range. So this is your basically, so you can use this to compare groups of data, because you can see that, okay, they all did better in Science than they did in English because they got mostly higher scores in Science. In Maths, there was a bigger range of scores than English and Science. So it's used for comparing data sets. So now that we've done this, what I want is you can write the same code, but using the female scores. Once again, Inamdi, please. Once you write it with the female scores, share your screen so we can see what you get, and then I will run, and then I will, if it should be what we've got similar, then I can run it and see what you get as well. Before I run it, if you can write your code, run it, and share your screen. So I can show you the code to write here. So the solution files has all the codes written, this is just for us to follow through. So it's just going to be the same thing as before. box plot, so I have to delete this. Female scores. So once again, you give it your labels. Use your curly brackets. So if you run it, and it should be similar to what you had for the male scores as well. So NMD, can you please run the code and share your screen so we see the outputs? Thank you.
So yeah, it's similar, but not really.
Okay, can you share your screen so I can see how it differs?
Yeah, I'm already sharing it.
Okay, sorry, I can save. So it's not, I mean, this is what I mean by it has to be similar, but I'm not going to look the same. But it looks like, so, but this is good. I like how you've shown both of them, so because I wanted to walk through that. So we can see now that if we had to compare between two sets of data, you can easily see that when we are comparing them, the female students, so that's the box plot on the bottom, they don't, they also have sort of the similar range. So their range is much smaller, isn't it? Because in maths, for the male students, the lowest score was 78, highest score was 92. But in the female students, the lowest score was 82. So the students for females, they got higher scores on average in maths than the male students. The range of scores is smaller as well because the scores are not so much wide apart. And the English is of the same level as they did slightly better again because their own smallest lowest score in English was around 85 and the highest score is still around 92. And in science, now, unlike in the male students where the science, they have similar scores that are more compact. So a lot of them scores the same scores on average. The ladies have more of a wider range of scores in science. So we can see that just by plotting the box plot, we can start making some assumptions. You can start some observations on the data, and we can start doing some analysis of the data to see, okay, in this data set, these students are maybe doing better. So maybe more female students are doing better in maths and more male students are doing better in science than in English. So it helps you to compare data. So then you can also then expand this and then decide to do another chart, maybe look at percentage of scores. You can then, calculate the average. You can add a code easy. So if you had a code that you say, okay, just write mean of the first graph. So if you write a code, so write mean. So mean, I meant average, MEAN.
Okay.
So if you open your brackets, and then we want to use so if you do all students, it's going to give you all of them like we've done before. So just use the all students group. Let's see what happens there and run it and see what you get. So run the section. So it's giving us, so it's going to give us in terms of each column. Yeah, so it's going to give you the column 1. So all students, so the all students data was this one. So that's not the one we want to use. So if we go back to mean, click the all students, erase that. Yeah. Use the male scores.
Okay.
Yes, so you can just use your tab to complete. and we run the section. So now we can see that the average for the male scores, the average maths is 84.4, the average English score is 85.86, and the average science score is 88.87. So if we now do that for the females, then we can also compare that kind of data as well. So that's what is good. So if you have to use the mean first and then put the female scores. Exactly. So now we can see how they compare. So we've already gotten some, so we could have, so when we looked at the box plots, we could assume this was the case, but by calculating the mean value, we can actually see that our assumption is correct in that from the box plot, we can always see that on average, the female students are getting higher scores in English and maths, but the male students have slightly higher scores in the science than the female students. So this is what box plots are good for. It helps with statistics, look at distribution of data. Does anyone have any questions? Thank you, Nnamdi, for sharing your screen. We can stop sharing now.
Thank you.
Okay, so for anyone, I'm sure this is going to be recorded and you can follow later on if you're not able to follow now. So I'm going to continue sharing my screen and move on to the next section. So Nnamdi already did this pie chart expert earlier on. So we're going to do the pie chart. So for pie chart, it's just to show proportions or percentages of a whole. So remember when Nnamdi did it, it was just doing 1/3, because with pie charts is going to mean that you have something that's going to add up to say 100 or something. It's going to give you in percentages or in fractions that how many percent of this data is blue, how many is red, how many is green, for example. So the data set we're using here is going to be the import pie chart data. So flavor column. So if I go back here, I called it pie chart data here. So you click here, we only have 2 columns of data. We have ice cream flavors and the percentage of ice cream that is that flavor. So this column here will add up to 100%. And we have flavor here. We have vanilla, chocolate, strawberry, mint, cookie dough, and other. So when we import the data, so we're going to import it just to check what I've said here again. So your flavor column as string, array, and percentage. So what we're going to do here is when we're importing this, because we want to import both the flavor column and the percentage column, I'll import it as a table. So import it as a table. You can see now when it was a numeric matrix, this column was red because it wasn't going to import that column. But now that is a table, it's going to import this column and it's going to give it these variable names, flavor and percentage. And what's table going to be called? I can give the table a name. I can call it ice cream, whatever you want. So it's a table and include unimportable cells again. Then we're going to import the selection. So we've got a table called ice cream flavor and it has 6 rows and 2 columns, sorry. If we come back here, we can inspect what we've imported called ice cream flavor. So we have this table where we have flavor and we have percentage, okay? So now we say we're going to draw a pie chart of percentage, flavors. I'm going to give it this title. So now, actually, because of how I imported it, I won't be able to use this code to draw it because I've actually imported it as a table, whereas I'm saying this is 2 different things. So what we need to first do is actually extract data out of it and say percentage. I'll extract from this table called ice cream. So when I want to extract data from a table, you will use the curly brackets, not the normal parenthesis brackets, because I want to extract the data itself. So if I do normal brackets, it's going to come out as a table. But if I do it, so I'm going to say ice cream flavor and I want the second, everything in the row, but I want the second column. That's the percentage. Then flavors, the same thing again. So ice cream flavor, I'm going to index into ice cream flavor, use my curly brackets, the first column. So what I'll do first is comment the section out so we can see how it works. We're going to run this section and see what we've got. So I did not use, so we've got percentage is this, and we've got flavors as a string. So now we can do our pie chart. So I'm going to then put semicolon so that I'm going to suppress this output. I'm going to uncomment this and run the section again. Now we've got a pie chart. So we can see here. Is that clear?
Sure.
Okay, thank you. So can we just try that now by creating a simple data set of your choice? So you can just create a data set by, for example, you can think of, okay, I've got a box of 20 balls of different colors, and then so you can say balls of different colors, so you can give it, and they have, you know, you can say balls, they have different colors, maybe 4 different colors. How many of them? So we have 10 blue, 3, so we have 10 blue, maybe 3 reds, 2 white, so we said 25 yellow. So that's an example. You can use whatever data you like. And I'll give you here the colors. Blue. So I'm going to give it, create my own string data set. Red, black, yellow. If I run that section, so I have these two together. So now I can create another pie chart calling balls, colors. Okay, so I hope we can all see we have something like this. Is everyone able to do this as well? Any questions? Inamdi, were you able to create your own pie chart?
I'm still on it.
Okay, so Augustine was about to say something.
Yeah, I was saying that the two that we imported the two as tables, right?
Yeah, so we put it as a table. Then that's why I had to extract the data from it.
And mine is saying undefined variable, ice cream flavor. So I didn't know what I could have done wrong or something. The ice cream flavor, is that something I supposed to have imported from the?
So when you imported the table, what did you call the table?
Okay, I renamed the table because the table, I renamed it as ice cream flavor because it was training data sets.
Yes.
Something like.
So if you rename it as ice cream flavor, it should run then, but check how you spelled your flavor as well. Is it O-U-R or O-R?
Okay, and Okay, am I going to import the entire table at a point? Because I imported the text and the flavor, I imported the percentage.
Okay, so if you've imported it that way, you don't have to do what we did. So because we imported it as a full table, that was why we then had to extract this. But because you imported percentage as a vector, I'm guessing.
Yes.
And flavor, how did you import flavor? Was it as a string?
Yeah, but now I've imported it as a table now, and it's up.
So if you import it as a table now and it's working now?
Yeah, it's working now.
Yeah, so it was because you imported as individually, you did not have anything for the ice cream flavor initially. So that's why it would not work. So because I imported as a table, I have to do it like this. But if you import it separately, which is what I actually said here, then you can also, so it's just showing two different ways of doing it. If you import it separately, then you don't have to run these first two lines of the code, basically.
Okay. So the task you're asking us to do this time around, we are not importing anything. We actually create the data sets.
Yeah, so you're creating your own simple data set just to see how to draw a pie chart without, because it's just a bunch of numbers and give you whatever you want to give it. And then something else is, I've done it to add up here. If it doesn't add up, it also does it for you. So it adds up to 20. But we can also do one where it doesn't sort of add up, and then you might, and sometimes if it doesn't add up, there'll be like a blank or something.
It actually speaks American English. It's American English we are typing into it, right?
Okay, I always don't know which one.
Or is that British, or because color, it's like I've made
I just typed it that way. I was one that typed it for some reason. Yeah, but obviously, American is colors without the U. British is color with the U. Yeah. But I was the one that typed it, so you could type it because I assigned that variable my name, so you could type it whichever way you wanted.
Okay, because I just want to like sure.
Hello, ma'am. Please, I've downloaded the software, but and also the folder, but I don't know how to upload or which of the folders to upload into the main MATLAB Excel sheet so that I can do some of these things you are doing.
Please go ahead.
Okay. Actually, if you can, I just need to take about 5 minutes break. Can Augustine show this lady how to do a place? I'll be back in about 5 minutes.
Okay, during the break. So she should share her screen, right? Yeah.
Yes, you can share a screen.
Okay.
Thank you.
Hello, Dr. Monica, you might want to share your screen.
Okay, I'm here.
So you will click on share screen so that we'll be able to.
That.
All right, it's coming up.
I've done
Good.
that. Are you seeing it?
So now you need to download this to your computer. So how do you click on, you see after share with me, there is ARN workshop, right? There's a downward arrow. Click on that downward arrow.
Okay.
And say download. So click on download down. Yeah. Yeah. And you can see it's downloading on your system.
Okay.
You see it zipping. Now it has downloaded. So you go to your download.
Okay.
Open that zip.
Okay.
I think you need to stop one of your phone. If either your phone has to stop the audio. Yeah. Okay.
Sorry.
So now check your computer where you have download.
Okay.
Check your computer where you have download.
Is here? This is my computer where I have download.
Yes, you go to my computer where you have your folder.
Yes, I've seen the folder.
You know, you go to your system. Okay, and oh, you are not sharing your system now. It's still showing the browser. So if you can share, if you can go to share and share screen, the first option, you can stop sharing and go back to share. And take the first option, which is you would see us like you are sharing the Zoom.
Okay, fine. I've stopped.
So
I
now
should share again.
Share again. Take the first option out of all those boxes showing. Take the first one.
Okay. And share. Is this one?
Now double click on that ARN folder.
Okay.
Right outside it, click outside and right click outside inside that box. Right click inside the box. Right click and say extract all.
Okay.
Yeah. So as it started extracting.
Yeah, I want to put it where I can see it quicker. I'm putting it on my desktop.
Go to So
ARN workshop.
Exactly. So if you go to you have it now on your what?
Yes. On
your
my desktop. I've opened it.
Now go to the MATLAB.
Okay, the MATLAB itself now.
Let's go to the.
This is it.
It's still showing your folder. You have to share.
So I have to stop. Okay.
You stop sharing. You take the MATLAB now.
You take MATLAB again.
Yes, you take the MATLAB. You share the MATLAB.
Okay.
Okay. Now that you are here, so you go to. You see where you have MATLAB. You have done documents before MATLAB, OneDrive. Go back to users. Yeah, go to users. Click on that user.
Okay.
Then on that users, take Prof FM. Yeah.
Okay.
Take Prof FM. Click on the plus beside it. The plus beside it. Yes. Go to where you have your thing. You say it's on desktop, right?
Yes, I save it on the desktop, but
it's not showing.
Let me go to the download.
Can you save it to, can you carry the folder and drop it in documents?
Okay, it's fine.
So you go to your computer, drop it in documents so that you can see it here. Please do that before our prof comes.
Yes, I'm doing that. Okay.
Then you can now click on documents now in that stuff. Oh.
Let me go to user.
Yeah, user. Okay, go to users. Go to users. Which one is yours? Pro M. Pro FM. Click on okay. Click on downloads. That plus beside downloads.
Okay.
Let's see. Scroll down. Let's see whether it is going to show the first one you downloaded.
No.
Oh, just use the import method then. Go to the home. Go to the home of that, what we call it, yeah? And open file. Open, click on open. Open, yeah, open here. Then locate where you have it on the desktop.
Document.
Yes, take that one, yes. Click on that. You can highlight, no, before you click open. Okay, open the ARN workshop, yeah?
Okay.
And then take data visualization. That's where we are now.
Which is this one?
Yes, that's where we are now. Yes.
Okay. The data is.
Can I come in quickly?
Please come in, Prof.
Okay. So because the way you've opened it, you're not working on that folder. You want to make sure you're working in that folder. So if you go to, you see where you're saying C users pro FM. Now keep going towards the left. No, so click the green button, the folder with the green arrow. Yes,
Okay,
browse for folder. So go back to the
Okay.
folder where you saved the information. Which folder is it?
Documents. But it's not there.
Where you save the ARN workshop file, is it in documents or download?
Yes, I have to move it to documents. Documents.
Okay, so is it, but it's not in this Pro FM document. So if you go to documents on the left, let's see. So
Okay.
So okay. Can you resave it into like your C document itself, not a different document? So you have to open it from the local drive.
So you want me to take it to the download?
Yeah, so if you show me the download of your computer, so we go to your Windows Explorer page. So I see where you saved it. Okay. Not from MATLAB, but from your computer itself.
Okay, so let me stop sharing this.
Because if you share your Explorer page, okay. So okay, so is it in documents? So where's the ARN workshop now? Is it in documents? What's in documents? So it's here, it's in downloads. Okay.
Yes.
So if it's in downloads, so you just want to make downloads the folder to work on. So if you now go back to MATLAB.
Okay. So should I stop sharing this and go to MATLAB now?
Yes. Yeah. Okay. So you can share your screen entirely, then you don't have to keep stopping sharing and resharing again.
Okay.
So if we go to that green arrow, I said the folder with green arrow, open folder. Yes. So the downloads. Yeah, so you have it. So click ARN workshop. No, just don't double click. So
okay.
Go back to downloads.
Okay. Okay. Select folder.
Wait, go back to downloads first.
Yeah, I'm in download.
Okay, I can't see. We are still seeing so click, so just click it once, then do select folder.
Select folder. Okay.
Yes.
I've seen it.
So now you can see that everything is now here. So you can be opening stuff that you want to open on the left. Okay,
so I just go to data visualization.
Yes, so that's the one we are working with.
Okay.
Okay.
Thank you. I will continue from there.
Okay, all right. Okay, so we go. So I'm going to share my screen. Okay. So the last part of this visualization section is going to be scatter plots. So with scatter plots, it's similar to line plots. Instead of saying plots, we use scatter. I think someone has to mute, please, because I'm echoing. Thank you. So, and then we're going to use the curve fitting app because with scatter plots, we sort of use it to also look at relationship between two sets of data, and it's used to see trends as well, the same way we use for line plots. But in this one, you can actually see that how does one data affect the other data. So you can say, okay, if I put this value for X, similar to equations, if I put value for X, how does it going to give me the value for Y? So the data we're going to use here is our house prices data set. So if we go back to our import function here. We have house decision data. So that's the sheet we want to open, house decision data. So now we want to import the data for the suburbs. So I've already sorted this data. So we have suburbs, rural, and city. So we have the number of rooms for the houses and what the houses cost. We want to look at how the price of the house depends on the number of rooms the house has. So we're going to import the data for the suburbs first. Okay, so if I click on both of them like this, I want to import it as column vectors, not numeric matrix. So I'll say, here I'll say suburbs rooms. So I'm going to change the name of that variable. So I'll call it suburbs rooms. Then I want to change this one as well to suburb cost. So I write a suburbs underscore cost. Then I'll import this set of data. So I actually did not, so let me make sure I have highlighted everything. I'm going to exclude rows with unimportable cells as usual, and then I'm going to import it. Is that clear, the import I just did right now?
Yes.
Good, thank you. So now I'm going to go back and we're going to now draw our curve. So we're going to say X. So now I'm going to assign again because I don't want to have to be writing suburb room, suburb cost in my program. I'm going to assign suburbs rooms to X and suburbs cost to Y. So that's going to change the X and Y I had when we started and I was doing the line chart. So I'm going to assign that to X and Y, and I'm going to say scatter X, Y. So I'm going to plot this here. Then I'm going to now use the curve fitting app to check the relationship. I'm just going to comment this out. So scatter X, Y, the same thing we do for plots. You can include your title. You know, you can call it title, just like we do for our plots, our line charts, title, and say house cost in the suburb, for example. Now, because I haven't put in this, it's not writing the way it's not. So once you put in your bracket, you can see that it's going to write, and it's going to become this sort of pink purplish color. You can label the axes as well. Remember your quotation marks. So X label is number of rooms. And the Y label, house cost or cost of the house, whatever you want to call it. So now we're going to run this section again. So we have our plots here. So now we can easily see here that there's some sort of relationship, like a line relationship, that as the number of rooms is increasing, the cost of the house is increasing. Even though we can see, like, you know, for 4 rooms, they have some variability in the cost, but it's sort of in a linear relationship. But to see that better, we use what we call our curve fitting app. So you now go to your apps in the top tabs here, open the apps tab, click the curve fitting. So it helps you to see relationship between data. We click curve fitting, it opens this new window here called curve fitting tool. Have we all opened that? For those of us working along with me, Inamdi and Augustine, and I think Monica as well, is it open?
Mine is open.
Okay, yours is open. So you can give it a name you want. So you can call it cost of house. Then we will now say, what's the X data? So we now choose which data from our workspace we want to be the X data. So you can say suburbs rooms, or you can say X itself. I use suburb rooms. So you see it's already starting to curve plot something, just giving you the suburb rooms. Then we're going to say Y data. We want the suburbs cursed. If we had a 3D data set, we can give it a Z data and we can give it a weight value, but we don't have that. Then it starts by doing.
Just a minute, please.
Okay.
When I open my own curve filter, it doesn't show the exact dialog box that you have here. Or could it be the version I'm using or what? Because they didn't show them.
So it didn't show the curve fitting tool the way I have it here.
Oh, but it's showing polynomial, it's showing table of fit, and it's showing a big screen for whatever, what we call it, select data to fit curve or surfaces.
Okay, so it might be the version. Were you able to select data as well?
Yes, now I think I figured it out that I would just like have to click on select filter, and then it came with a small box. So that's where I can say fit name XY. So I think that's fits into what you're doing. Thanks.
Okay, so what version do you have? The MATLAB version you're using? Do you know which version?
Is let me see, R222B.
Okay, so maybe they've changed because I'm still using 2021A. So
Okay.
it might have changed in the newer versions because I haven't updated to the new version yet.
Okay. Thank you. Thank you.
So that's a good question for anyone else. So depending on the version you're using, it may look slightly different from the way mine looks, or you should be able to enter the data the way Augustine was able to figure it out as well. So, and then it starts with like this sort of, it comes up with what it thinks is the best fit, then you can change it. So when you see the polynomial fit, you can see that it's drawing a line, which is what we think. Degree of 1 is basically saying it's a line. If you go for like degree of 2, it's going to become more of like quadratic polynomial, like a quadratic equation. But we already saw that from drawing our graph, it's going to look like a line because it looks like it's a linear relationship. And then you can see the model here, giving the coefficient. So it's P1 times X plus P2. This one means that if we have a value, so we can say if X is 6, so if we use this coefficient, we can actually predict what we think the cost of the house should be if it has 6 rooms. Our data here only extends to 5 rooms. But based on this data, we could then predict what we think it should be if we have 6 rooms, for example. And you can look at the goodness of the fit by looking at the R square value. So that's the sums of squares of error. You want that to be as small as possible. Then the R square value is 0.92%. So it's similar to regression for people that have done statistics. So if this is high, then that means it's a good fit. So what you can do is you can play around with this. If you change this to a linear fitting, for example, this is still good because it's linear, but it's a much different type of equation. So y is equals to f of x, which is this. If you want to go for polynomial, probably not give you good fit. So if you go for a power interpolation, is 92%. So it still gives you a good fit because it's sort of like a very simple data set. The rationale you won't be able to use because, so you can see the rationale. Exactly. So this does not work. It does not have, so this is giving you a negative R squared because a constant, the fit is poor. So the fit is poor. So sometimes you cannot use this kind of fit to fit this data that we have. So we can just play with, what you think. So here you don't have unique values, so we can use interpolation method. Smoothing spline sort of still works, but even you can sort of already know that it's not the best. That this kind of data, we are better off using our linear polynomial fitting with 1 degree. So that's how you use something called the curve fitting tool. And once again, you can also show some other things. So if you come to this part of it, you can look at the residuals plot. So the residuals plots, want them to be close to 0 as much as possible. So obviously you have the ones where there is a bit more of a range, is higher. This is smaller, this is higher as well. So residuals just tells you the difference between the cost of house, the average that it has sort of estimated with this line. So that line is like the line of best fit. And how does the data points differ from it? So these data points are far away. These are closer to it. So the closer to the zero line is the better your predictive power, basically. Are there any questions for this one?
Get to plots on now, or how do you create the residual one? Because I have the first one.
So if there should be a place where you can click. So if you can see where I'm clicking here, it's called residuals plot. So when I clicked it, it showed it. If I click again, it's going to disappear.
Where is that? Okay. Is it on the bar?
It's on the bar. Yeah, it's in the toolbar.
Okay. And okay, I've seen that. Thank you.
Okay. Then we can do a contour plot, which I'm sure we can't use because we don't have the kind of data for contour plots. But if you had, you can also introduce that to it, basically. Okay, and same as before, you can go to file where you can then print to figure. So this curve that we've got, we can print to figure, and then we can also play around with it in the figure tool for MATLAB, just like before. So if you want to close, you can save the session. So you can save your curve fitting sessions and then come back to work with that same session, or you can clear that session and load the new one. So I'm going to save the session. I already had it before, so I just save it with the same name. So I'm going to override the one I had initially before. It's going to ask me, I'm going to replace it, yes. So that's what you can do. And then we can close the curve fitting session, or we can do a new one. So now what I want everyone us to try is the same thing we've done. Do it for the city data and the rural houses data and see how the three of them compare. And actually here, I wrote a code here where I looked at the correlation coefficients between my X and Y. And when I did that, it gave me answer similar to what I had from the curve fitting app. So if I run it now, we have a correlation coefficient of 96%. So it's about 0.9597. So how much this data correlates is about 96%. So we do the same thing for the houses in the rural area and the city area. We can then compare that between them, which one has good relationship between the number of rooms and the cost of the house. So for that exercise, to get you started on writing the code, the first thing is we're going to have to import the city and the rural data. So we go to our import file. Now we're going to, I'm going to highlight all 4 columns of data because I know that I can change the name. I want to be column vector, so I'll just come back here and change the names before I continue. So rural rooms, rural cost, city rooms, city cost. Then I can now import them as column vectors and import all of those selections. So I've got 4 of them. So now coming back to MATLAB, we can then plot it. So one thing you can do here is you can actually just use this here and not use this. So if you want to use the same code I wrote before, you just edit it. So instead of suburb rooms, we change this into city rooms. City cost. And then we edit the name the title, house cost in the city. Now here is where we're going to do something so you can keep saving them. So this coefficient, we now call it city, so that it's going to save it into city, and we can check that later. So if we run this section, we can see the data for the city. So we can see that for the city, the correlation is a bit different. So it's only 60% correlation. So it's not highly correlated between the number of rooms and the house cost. Then if I change the data again to my rural, so that's why using things like X and Y works, because we just edit what we give to X and Y. So we call this, the reason I'm changing the title of the curves, you could be saving the curves as you're going along. So I can first save this curve before I do a new one. I'll save it as house cost in the city. So then I can access this curve later. So I'm going to rerun this now. Now change this as well to rural. Run section. So we can see that similar to the suburbs data, rural has 96% correlation, and we've saved it. But we didn't save the correlation for suburb and the figure, so we can go back and do that. So once again, we'll save our table. We can save our figure. So we have this figure called rural, and then I can go back and do the one for suburbs, so you can save it. So, and then if you want to do another curve fitting session with this data, you just come back here and change it to city rooms. City costs, and we can see we've got our this thing, and we've got our house grade. Now, because we said initially that it looked like the city is not as correlated. That's why you have this sort of goodness of fit of 37%. So because of the correlation is different, it's not as correlated for the city than it as opposed to the suburbs and the rural data. So you can see that comparing them, you can already see here, because you have these big outliers. So it's not as correct. So you may need to play along here with different types of correlation. You might say, let's say if we use 2, is it better? It's slightly better if we use quadratic, because we have a 53 goodness of fit, but the sums of squares of errors is very high. So again, I wouldn't recommend it, because you want your SSEA sums of the squared errors should not be this high. So this is like a very high times 10 to the power 10, and it's not like it's negative. So that is not very good either. You can try to robust it and play around with things like this and see what you get. So it still just shows that you can't really fit data for this particular one because of the way the data is. But if we use linear fitting with a sine wave, there's a bit of fitting. So it shows that for the city rooms, we may need more data to correlate. Because also one thing when you're doing this kind of scatter plot is your number of data sets. We really have limited number of data. So if we have maybe another 10 data sets, then it might be that there is a correlation with these two just being the outliers. So you may need to increase data set to be able to see more of correlation here. But if we go back and check the rural data, no, I meant to use the rural ones. And rural costs. So with rural data, linear fitting seems to work, but we go back and look at polynomial fitting, and we want to use degree of 1.
What was the degree used before? Sorry, the degree used before.
So it was 1, but for the city one, I moved it to 2 to check if that can give it a better feet.
Okay. Because I was thinking you mentioned the quadratic.
Yeah,
option.
so if you use degree of 2, it becomes a quadratic.
Yeah, okay. Okay, thank you.
So here we can see that the sum squared of error is smaller than in the previous one. So it's still a high number, obviously. But okay, once again, like I said, if you have more data, then you can start to have a better fit. So you always go to collect a lot more data to be able to really see the relationship. Because of our limited data set, we can't really see, but we have more data set, then we're able to get a more accurate relationship of how they compare. But once again, we can see we have an high R squared here that shows that there is a bit of a relationship that we can see with this information. So with the data for the rural houses and the suburb houses, there is relationship. For city houses, there isn't enough for us, there's a relationship. So because of time, I'm going to stop there, and that's the end of data visualization. So I think what I'm going to do is, because we still had the machine learning one to go through, so now I'm going to, I don't know, I was thinking, because we spent quite a lot of time on this, and there is an exercise for this on drawing box plots for people to try out. So I was just thinking right now is, do we to ask the Augustine, the organizers, do we think maybe it might be best to do another session in a few months' time to go over the machine learning part? Because I'm not sure we can have enough time to go through it for people to be able to understand it now, or do you want me to continue? Because I've created 2 things. We're going to do machine learning, so we're going to do classification and regression, and I would want people to be able to at least follow through and try it themselves. What do we think?
Thank you so much, Dr. Khadijat. We really thank for your time, and it depends more on you, because we have some advanced, at least about 2 or 3 advanced participants here. So it's also good to get their view, like Kenneth, as well as Nnamdi, so that we'll be able to know if, but for me, I'm happy to, if you're happy to continue, I'm happy to follow along, because it's interesting.
Okay. Yeah, because we only have 45 minutes, so I would have to move at a faster pace.
Okay, Ken.
To run through the other 2, because it's still a big, it's 2 big areas. So that's why, if you want me to continue, I can continue and just do as much as we can do. So Kenneth and Nnamdi, what do we think?
I'm thinking personally that maybe we should just skip and come and go to the assessment project. Why I say we should go to the assessment project is, we should go to the assessment project and everybody should go and try their hand, and we'll set up another class where we can correct ourselves and properly learn the machine language. Because I don't want that to run through. I know most of the people that are here, some of them that are not used to MATLAB, they are seeing everything like magic.
We can't hear him anymore.
Sorry, can you hear me now?
Okay, I can hear you now.
Yeah, I said I'm thinking we should just jump to the project section. The reason is so that we can go and try something on with the project session, and maybe fix another time where we can come again to go through what we've done in the project session and the machine learning again, because there's more of the work to do. More of the people here, some of them have not really gotten into what we are doing because of this, their first time. So they need the hands-on on the MATLAB so that they can understand what they've been taught, as in what they've gone through, and come back for questioning and answer. I think we can set up another meeting sometime, maybe next month. Next month is not far, on a day like this, so that we can run through all these things for me personally.
Okay. So I think we should have
Sorry, I agree with Mr. Ken, because some of us here, we are from different fields or specializations, and this is my first time of using this MATLAB or even having access to the software. although I'm from the demography and sociology, I use the Stata and I use SPSS, but though it's a little similar with Stata, but I'm still confused. I can't tell you that this is what I've achieved for this program, but I've told myself that on my own, I will sit down, read what MATLAB is all about, and then do it all by myself. Yeah.
Thank you very much, Moni. So Namdi, what do you think? Oh, no.
Oh, okay. So leaving it for another time is okay, but if it's going to involve MATLAB, and we all know that those of us that are on a month subscription will run out in a month. So I think it's better if we can power through it and now refer to the recorded session whenever we encounter any problem. Also, there is that, I think there was a mention of Google Classroom where we could meet and share further ideas. Because I don't think we might have this opportunity to come back together again, clear the schedule for a day.
Okay, that's true. I just thought about the fact that, thank you. Some people are on the trial version, and I can't say that I'll be free within 30 days. So I'll try to go through the machine learning and the regression one. So you can always watch the video, pause, and follow along. So what I'll do is I'll just be walking through it myself. I won't really ask you to do anything to save time so that we can finish in the next 40, 50 minutes, hopefully. And then people can type their questions in the Google Classroom for us to answer. And then what we may be able to do is, even if, because I obviously still have access to MATLAB, if there are some questions, we may be able to set up another time where we will just use it to go through the questions, and I can just show you how I would do those things in my own MATLAB, even if you've lost access to the trial. I'll just be able to see how to. So if I go through it now, and people on trial version can try to make sure they practice it within the next week or two, have their questions put into the Google Classroom, we may set up another session where I can then show you how to answer those questions by just showing you, even if you cannot follow through, you've already tried it so you can see how it's done. So I'm just going to continue now with the machine learning. So now I'm going to close this one here. And so if you want to save your workspace, so one thing I was going to say, everyone should try and save their workspace so they can access what you've already imported, and you don't have to import it all over again. So to do that, you can go to this save here. No, actually, if you go home, you can click on save workspace, or in the command line, you can write Control S, and it brings this up, and then you can save the workspace as visualization workspace. So because I already have one called visualization, I'll change the name to visualization (24 June). So I know which day I used it. So just save whatever you want to call it and say, because if you have the data files I sent, you already have a visualization workspace in that data. But in case there are changes to what we've done today and what was inside the old one, you can resave this as in a different name, so you can access both of them. So once you save the workspace, you can then clear the workspace. To clear the workspace, just type in clear into your command line, and then it clears the workspace for you. You can clear your command by doing CLC. So then we can work on the machine learning one. So we're going to open, the first one is classification.mlx. So we open that one. So here we're going to use MATLAB for supervised learning. So the first thing when we're doing any classification, it means that we have some sets of variables. We want to see how combined together, those sets of variables can help us to predict another variable. So that's classification. To not even predict, to classify sets of data. So we have data that belongs to certain classes. We want to see how the variables, we call them the predictors, can use to classify those data into the different classes they belong to. So what we're going to be using here is the Fisher Iris data set in our import. So we have a Fisher Iris data set here, the first sheet. So in this Fisher Iris data set, we have four different features, we call them. So we call these four things features: length of their sepals and width, and length of the petals and width. And it's given for three different types of species of flowers. We have setosa. If you scroll down, you have versicolor and you have virginica. So we have three species of flowers, and we have this information to differentiate them. So we want to see that by training a model that takes in this information, it can classify the type of flower. So it means that what you now see, we have new sets of data where you have a sepal length, a sepal width, a petal length, and a petal width. You can feed it into your model, and you can use it to actually find out which type of flower is that flower possibly going to belong to. It's not always going to be correct, but by using examples, we can create a model that has some accuracy. So we're going to first import our data now to use here. So once again, you have the solution as well that you can use. Well, this one here wouldn't have a solution actually. Just follow what I'm doing and you save it, because I'll do everything on the classifier app. But you have this file that tells you, simply gives you sort of the figures you should be expecting when you run it yourself. So this is good. So that's what I've done here. So we're going to import it using the import tool, and we're going to split our data into training and test data. So first, we're going to import the whole thing as a table, because that means that we can keep the different kinds of categories. So I'm going to include the setosa in my importing. So I'm going to import everything as a table, give it a name. I can call it data for training, or I can call it data, because I'm going to still split my data set. So I call it data. And then I'm going to exclude rows with unimportable cells. I'm going to import everything. So I've got 150 sets of data times 5 columns. Now that I've imported it, I have what I've called data here. So now I want to split it. So because of in this data, if you examine this, it's all 1 to 50 is setosa, 51 to 100 is versicolor, 101 to 150 is virginica. Now, before I can split it, if I just split it 80-20, then it's going to mean that the first 80% will be the first certain amount, then I won't have randomized version. So I want to make sure I can randomize it. So I'm going to create a random set of variable called C is equal to rand perm 150. So it's going to give me randomized integers from 1 to 150. Then I'll now create from that, I'll take the 80% is 120. So the first 120 of those will be my trained data, and the remaining 121 to 150 will be my test data. So if I run this section, you can now see that in this randomized C, you can see that is 1 to 150, but the numbers have been randomized. So it means 96, 72, 147, 5, 13. So what this means is that when you come to this data, and I'm using it to edit by saying 1 to 120, it's going to take number 96 is now going to be that the first one is going to take, is going to create, you're going to data, pick the 96th data value, which is 5.734.21.2, and that'll be the first thing in my trained data value, 5.73, and it's versicolor. So it's going to now do that for all these numbers. So instead of indexing it in terms of 1, 2, 3, you'll index it based on the numbers here. So 96, 72. So that way you'll be able to have a randomized version of your data set. So if you look at your trained data, you can see that some versicolor, some virginia, some setosa. So I'm going to make sure I have representation for all three in my training data and my test data. So what is my training data and my test data? My training data is this I'm going to use to train the model. So I'm going to give the model some examples with the answers for it to learn, to see the relationship between the classes and these features. Then the test data I'm not going to feed in to test if my model is doing well. So you can train a model, is doing very well. When you put in your test data, doesn't give you good result. That means you have to check your model and make some changes. So that's what we're going to do. So in MATLAB, you can write a program to do your machine learning yourself, but actually it's good to use the apps. So we're going to be using the apps, and I'm going to now move on to using the classification learner app to find the classification model to train this data. So we are going to go to apps. We open our classification learner. We have a classification learner. So if you need help with this, you can always click the help button to help you with how to use the classification learner app. Then is new session. I'll say I'm working from my workspace because my data is on my workspace. If it's on a file, you can import the data already from a file, but it's good to have it in your workspace. So I'll say from workspace, a new box comes up. Now select data to input. So I'm going to input my train data only 120 times 5. Then it already says that, okay, my response is from my data set variable, because I know that the 5th column is the species. So that's the response. So I can say, if I didn't have my response here, I could say that, okay, from workspace, and I'll choose what I want. Because I know that it's from my mix, and it already says that this is categorical, it's 3 unique. So that's the classic. So there are 3 different classes we want to classify into. And this is going to be our features, so our predictors that we're using to do the classification. Then here you have validation. Do you want to validate because you want to prevent overfitting? So you create into different sets of data. So, and then you estimate accuracy. I'm going to use 5 validation cross validation folds. It means that when you use 5 cross validation folds, it's going to do a first fold where it uses that as the validation and use the other 4. They're going to keep iterating that and do that 5 times. Or you can do all that validation if we have a large data set, but we don't have a large one. So we're going to use a cross validation or with substitution validation, so it doesn't protect it, but you want to use one of these 2. If you have thousands of data sets, then you can use hold out and say, okay, keep out 25% and test with that. But because we only have 120, we use cross validation. We choose that. We say we want 5. We can do more than 5, but I think 5 is enough for what we have. Then you start session. If you wanted to find out more, you can always click, how do I prepare my data for classification? I can read about validation, so you can use that to do a bit of learning before you do this. So we start our session. When we start our session, our data has been imported, and then we have a scatter plot that we can see already. So we can first view with the scatter plot. Remember with the scatter plot initially to see how do they compare with the classes. So these are the 3 classes. We can see that there is a bit of, this is a sepal width against sepal length plot, and we can see there's a distinction between the setosa and versicolor and virginica. But versicolor and virginica, they seem to have similar features, so you cannot really distinguish. So you can change your Y value and say, if I plot sepal length against petal length, for example, once again, it's the same thing. We can see that it's easy to differentiate between setosa, but the other 2 are more similar. That's why we need our model. So we can see that setosa is a bit of a distinct class. The others are related. So that's why you need to do your model to see. So we're going to use what we call the decision trees. Now, in terms of what kind of models, you need to do research on types of different kinds of models and how they work. You have what we call support vector machines. We have different ones here. This one is not going to work, so it's not going to allow it because of the data we have. So I'll say if you want to be doing classification, you need to make sure you check the kind of models that work for the kind of data you have and use that. Choose the models here. So if you know the data you want to use, you can try different ones, or if you know the one you want to, you can go to that one. So we're going to use the course tree model first. Then we already choose that. We can look at the advanced and tune advanced model options. I'm not going to do them. I'm going to use whatever is going to be the MATLAB default version, and I'm going to train. If we use parallel, it means that you can use parallel toolbox and train 2 or 3 different models at the same time. So I'll click on train. So you can see it's just trained and it tells you the accuracy based on the validation is 91.7%. So now if you want to view the results of your training, go to confusion matrix. So the validation confusion matrix was going to be plotted. So now this is telling you that all the 41 setosas were classified as setosa, but in versicolor of the 40, 35 was classified as versicolor, 5 was virginica. So there's an error here. And in virginica, of the 39, 5 was misclassified as versicolor, and 34 was correctly classified as virginica. So these are the correct classifications. They form a diagonal. So you can see that this also correlates with what we saw when we looked at initial scatter plots, that the versicolor and the virginica flower species, they have some similarities that is causing some misclassifications there, whereas the setosa seems to be distinct in its own. We can also now use this here called parallel coordinates plots after you've trained. So if you look at parallel coordinate plot, you can also see that it tells you which feature is best to differentiate. So we can see that actually the petal width feature helps to differentiate very well, because you can see here setosa is distinctly away. There is with versicolor, then virginica has some here as well. So we can also continue to play with different types of features. So now we can do what we call feature selection. So if we don't want to use all 4 in our model, we come to feature selection and we say, okay, we see that petal width is good. With sepal length, there is a bit more of like, there's quite a few joining and coincidence, mixture. So let's take out sepal length, for example, and only classify with these 3 features, okay? So we close it. Then we go back to our decision tree. We use the same cohort tree again. So we come here and we say we want to use cohort tree. So train that, and we train it again now. Now we're using 3 out of 4 features. Now we remove that feature, but actually our accuracy is still the same, 91.7%. So it didn't seem to have made that much of a difference actually when we trained it. So that tells you that, okay, even if we use 3 out of 4 features, it's still sort of the similar thing. What if we take out sepal width and leave sepal length? So we go back to our feature selection, leave sepal length, take out sepal width, for instance, train it again, see if you get better. So accuracy, so this tells you that, okay, what this is good for is that by seeing that you can remove the features and train, this is good for when you want to collect data and you don't have the capacity to collect a lot of data. So if you can see that the accuracy is not that much different if I use 3 out of 4 features, it means that if I want to collect my data, I don't necessarily need to have all 4 features. If I have 3 features, I can still get a good classification. But let's also look at the confusion matrix. Again, it's the same thing as before. It's the versicolor and virginica that are misclassified the same similar way. So we can see that there isn't that much difference if we use 3 out of 4 features. But what if we use 2 out of 4 features? Is it going to be better or worse? So let's take out the 2 of them. Only use the petal length and petal width now. Okay, so when we use only petal length and petal width, once again, 2 features is still the same thing. So this tells us that for this set of data we have, we don't need to have all 4 features for us to get classification. Now, this is all for the training. Now, if we can we test this and see what we get? But before we do that, now we're using the same model, cohort tree. I'm going to try a second model now called SVM, for example. Let's try the linear SVM. So that's support vector machine where we're using a linear separation. Actually, I'll try the quadratic. Let's try this one first. Now using the 2 features, I'll use all 4 features to start with. Now you see with this SVM, we have a better results at classification accuracy for the validation data. There is still errors with the versicolor and virginica, but for virginica, only 1 misclassified data, and versicolor only 4 misclassified data. So that tells us that SVM is probably working better with this data set, with these features that we have than the cohort tree. This is how you can test different types of classification models to know which one is better. So now you've used your validation. Now we're going to test with our test data. In new MATLAB now, you can just put in your test data here. So if you didn't have this kind of version, let's put your test data here. What you would normally do is you will export the model. So you choose the model. So I want to use this 5th model. I'll come to export this model. So I'll export the compact model because I have the training data in my workspace anyway, or you can use this like this. So I'll export the compact model. I'll give it a name. Let's call it trained model here. Say okay. So when I export it, I'll come to my MATLAB window here. So it's giving me something here. If you read your command, it says that variables are being created in the base workspace. Structured trade model has this. To make any predictions, you have to use this. So this tells you the code you have to write to predict from this data. So what you need to now do is to make a new prediction, you just use that code to write the prediction. So you can see what I did initially before. Now, one thing you can see here is that when I ran this yesterday, and I wrote it 2 days last week, 2 days ago, I had a training accuracy of 94.2%. Why? Because when I run this randomizing is randomized. So I'm not going to get the same data set as the one I had in the one I did before, which is why when I run it with the same cohort tree, my classification is accuracy is slightly different with the four features. So every time you run it, you're going to have something different, but it would look something like this basically. So you wouldn't get the same numbers, but you get something similar. Then we've not tested yet to look at our test accuracy. We're only looking at our training accuracy so far. We haven't looked at test accuracy yet. So after training it, so now to go back to it, so if you don't have the MATLAB version that allows you to put in your test data into the app, you can use this. Then you just write a program called y-fit is equals to train model predict function bracket t. T will now be your test data. So just to show you what you would expect to do is you will say y-fit is equal to trained model dot predict function. So you write it the way they've written it, then you just put in t. So what's t in our case is test data. And then you enter, it runs it, and then you see your solution. So then you can compare that to draw your confusion matrix. But since you can do that with the app, I'll suggest using the app. So back to the app, I'll import my test data. So it's going to ask me what's the test data you want to import. I'll select my test data. So test data here. And the predictors, the response is this. So it's going to compare the predictors are this, and I'll import that. And I'll click on test. So it's going to test all the models with my data. So when we looked at test, what can we see? We can see that with our decision tree, the cohort trees, we have 96.7% accuracy with our test data. But with SVM, we have 100% accuracy with our test data. So you can also view the test data confusion matrix plot here, where you can see that all of them are accurately predicted. Then you can also do what is called the receiving operating characteristic curve to see the true and false positive rates. But because we have 3 different classes, you have to be changing your true and false positive in this case. So I'll leave that one. But your confusion matrix is what you use to see how well your data, your classification model is doing. So then to save this, because this is the one that is working the best, what you then do is you go to export plot to figure. So here you have the export plot to figure, and then you can save it. You can say give me the model 5 linear SVM. Then you can save your figure as, so you go to classification output and you can save it as linear SVM test confusion matrix. So you can say linear I'm calling linear SVM, so I want to know which model it is. Test confusion. And I save that for me to save for later if I want to be able to save that. If I'm writing a project, I want to put that figure into my project, and I'll then do my write-up. I've saved it, I can use it later. So, because once you close it, you lose access to all of this. So once again, if you want to take the one for the training, that's the validation one, you come back and do the same thing again, export plot to figure, and you save it, whatever name you want to save it as. So is that relatively clear for everyone?
I think this is interesting to me because, you know, using the classification learner really saves someone from coding. So because all this thing, if to do it outside MATLAB, one has to be writing several lines of code.
Yes, you have to write the lines of code. So if you want to see what the code is, you can generate the function here that gives you the code, if you're interested in that. But obviously, this tells you that you can do it without, because you can generate a function where you can see the code. And this is good for if you want to use it with new predictors, new data, you can edit this code and do it that way. But if you don't know how to code, you can easily just do it by having your data prepared and using the classification learner app to extract everything you want to extract. You can get your plot, you can get everything, and then you don't have to know how to code. So that's the good thing about MATLAB, is that you don't have to know how to. There's a lot of click and point and click that you can do without necessarily knowing how to code. But if you're interested in the coding app, you can go back and see, okay, if I want to be able to code it, I can make all of these changes, I can do that. So it's also good for that. We want to learn how to code.
And again, thank you very much. I don't know if time still permits you to explain the idea of machine learning and the whole concept of test data, and train data to people who are just new to machine learning, so that they'll be able to know, okay, what's the goal of all this pattern, you know, towards a kind of, you already have the data you have collected and you have, it's really very good. No.
Okay, so I can just try to explain it. So what we say machine learning is basically we are using your machine. The name explains itself. It's learning. When I say it's learning from the data have fed into the program, into the machine. So that's why I say machine learning. So for example, when we say classification now, we call that supervised learning. Why we call it supervised learning is that because we have our answers. So if I go back to the initial data set, right? We have this data set here. Let's see if I can, okay, it's here. So we have this data set here called data. So this is the one I'm looking for. So we have this data here and we have 4 columns. Now these first 4 columns, we call them features. So I have some kind of flowers. Someone has gone to look at 3 different types of flowers. Then they have taken some measurements called the sepal and the petal. So they measured the length of the sepal of that flower and the width of the sepal of that flower. They measured the length of the petal and the width of that petal of those flowers. And then they've now recorded that data here. So they're not saying that all this, so they looked at setosa flowers and they had this information. So the first setosa flower, so it's like, you know, you take your first flower, you measure the length of the sepal and the width. Same for the petal, you record it. The next setosa, so they looked at 50 of those setosa flowers, recorded the data. 50 of the versicolor flowers, recorded the data. Another 50 of the virginica, recorded the data. So you've got this data now. What you want is that you want a scenario whereby if someone gives you a flower that you don't know if it's setosa, virginica, or versicolor, I want to use this information to figure out if this flower setosa, is it virginica or is it versicolor? That's the point of classification. So to do that, you want to create this computer model that if you feed in the data, so if you just go and get the length and width of the sepal, the length and width of the petal, if you feed in those 2 sets of data, 4 sets of data into that computer model, It's going to run and it's going to predict. It's going to tell you that based on the figures you've given me, I predict that this flower is possibly, now I'm using the word possibly because we can't say we are always going to be accurate. So this flower is possibly either a setosa, a virginica, or a versicolor. Why is the word possibly is that it's using relationships based on what you're feeding. So, but for the computer to do that, it needs to have learned the relationship between the length of the sepal, the width of the sepal, the length of the petal, and the width of the petal. So to learn the relationship is why we have to feed in what we call the data set with the answers already. So that's where we come with supervised learning. We have to train our model first to learn the relationship between the 4 features we have collected. So now going on to why you have to do a training data and a test data, because you need to be able to test what you've done. It's same as when you go to school or you do a workshop, you learn something, then they test your knowledge. So we're telling the computer to learn relationship between the sets of information we've given it. How do we test that the learning the computer has done is going to be accurate enough? That's why we're going to create our training data and our test data. So we take our training data. So usually people can do 70-30 splits or 80-20 splits, depending on how much data set you have. If you have a large data, you can do 70-30. If you have not so much, I've used 80-20 so that I have a lot more for the training to ensure that the computer, the program is going to get enough information to learn accurately, and I have just a little left over to test it. So one thing for machine learning is the more data, the better, the more accurate your data is, your model is going to be. So I created this data set. So I now split it to training data and test data. That's why I had the training data and test data sets. Now, when I'm doing my initial learning, so I'm training in the classification learner app, I use the train data to train the model. So I'm giving it information that it has the answers to. So the computer itself now, here, when we click train, what it's doing is that it is looking at, based on the kind of model I've chosen, a decision tree works differently from linear discriminants. So here they say it creates, a linear boundary. So you need to sort of look into the different kind of classification models you can use based on data you have and choose which one you think works well. But once you know that, you can always try different ones. So here is the decision tree. We have the naive Bayes. Support vector machine is used widely because it works well, and also k-nearest neighbor. So with k-nearest neighbor, what you're doing here is that you're taking, say, 5, you use one data point, look at 5 different data surrounding it. And then based on the 5 data surrounding it, we decide on which one it's meant to be. So we say the closest one to it is the class we'll predict it to be. So you can use different kind of classifiers. You also have neural network, which is a bit more advanced. I won't go into that, but you can read about it. So you choose your classifier. You will now train your model to learn the relationship between the features. So we call them predictors. That's why the first one here, I use all 4 features. So it's looking at what is the relationship when sepal length is 5 and petal width is 2 and sepal width is 6 and petal length is 3, we say it is setosa. So the computer is doing a lot of things that we cannot do ourselves. So its computation is doing things and making connections between what they are, which is why you look at this parallel coordinates plot. We said that you can see that when you come here, there's a bit of a distinctiveness in the data itself. So because you can look at the scatter plot of the data and see that, okay, you can make a distinction between the setosa and Judea, but this is why we need a model, because when it comes to versicolor and virginica, they have similarities. So the model can then go beyond the similarities and find the hidden discriminations that are between them that we do not know. So that's what the computer does. That's what the machine learning model is doing. The model is learning the relationship between these features that we have fed into it, then using that, training and learning that. So that's why when we're training is learning that and saving the learning that knowledge is gaining into that model. So when it saves it, and that's why we do the validation during the training. So what the validation means, the cross-validation, is that you take this 120 data set, you split it into 5, right? So it's in 5 groups. We split it into 5 different groups. The first group, it takes the first one. So let me see if I can just use the whiteboard to show you what I'm trying to do. So I'll stop sharing my screen. So I have, I now have group 1, 2, 3, 4, and 5. So what's going to happen is that I'll leave out this first group. I'll take these 4, right? Train with this 4, test this 1, check my validation score. So maybe when I do the first time around, because this is the first time, I get maybe 40% validation. I get maybe 40% validation in this first one. I get 40%. 40%. Now, I will now go back again. I will leave out the second one. So I'll leave this one out. I'll train with the first and this one. So that's I'm going to do it 5 times. So I'm leaving one now, leave our second one, train with the first group and group 3, 4, and 5. Test with group 2. By now, I would have learned better, so I may now have 60% accuracy. The third time again, I will leave out the third group, train with group 1, 2, 4, and 5, test with group 3. My accuracy should have improved to maybe 60, 70, or 80%. Same thing again, I will leave out group 4, train with group 1, 2, 3, and 5, test with group 4. It should have improved. Then finally, I will train with group 1, 2, 3, and 4, test with group 5. So this way, I have trained with everything and I've tested with everything in the data sets. And that's when by then I should have my highest validation accuracy. So that's why we call it 5-fold cross-validation. If you did 10-fold, you split data into 10 groups and do the same thing 10 times, basically. So that's how you do your cross-validation when you're doing your learning.
Thank you very much. And that means it depends so much on the data set one has already gathered. That's what one is.
Yes.
Thanks.
Yes, you have to, it depends on the data you've gathered. So you gather your data. So it may mean that sometimes you have to go back and get more data. You talked about feature selection as well. You can do something called principal component analysis. So this one is that the computer itself finds the features that are best based on what you say. So we say explain variance. So we say of all our 4 features, how many of them explain variance of about 95% or 99%, for example? If you choose that, so if I choose that now, and I run this data again, I'm going to use my SVM to run it. So it's going to decide, so instead of me saying which features to use, this is going to choose the features itself. So because I chose to explain 95% variance, only 2 features did that. But you can see my accuracy is smaller, it's 94.2%. And I had higher accuracy when I used all 4 features. So I can go back to my PCA. So PCA is good for when you have large features. If you have like maybe data sets of 1,000 features, and your computer is going to be so much computing power to run with 1,000. If it's a PCA can bring that down to maybe 700 or something for you, which is going to be much lower. So that's the advantage of PCA. So if I say 99%, I would expect to take more of the features now and train with that. So now it's using 3 out of 4 features and it gets 97.5%. So now we can see that 3 out of 4 features is what is used after PCA, and then which one of them. So by looking at the order in which it is, we can know which of the features he used. So it looked like he did not use the sepal length, sepal weight, petal length, but did not use petal weight because that's 0.5%. So you use the first 3 and you get a better accuracy of 97.5%. Then if you test your data with that one as well, it's still good. it's still a good model. So we thought that we can use 3 or 4, or we can use all 4 features. But that's one thing that we can do. If you don't want to do your manual feature selection, you can use PCA for automated feature selection. And then we will now use our test data, like I explained, to test our model. So once we test our model and it works, it means that data that we've not seen before feed into that model, and we can have we can have some trust in the result it's going to give us, because when we test, there's 100% accuracy. So maybe if we increase our test data set, it may not be 100%, but it tells us that we can have, a level of comfort, we can have a level of trust if we use this model, because it seems to work really well. Any other question?
This is the time to ask questions. Okay.
I think everybody will still be confused going through, because their memory will be full now, seeing what you've not seen, seeing what you've not done before, with so much data, so much analysis. So I think most of us, our brains are already congested now. So we have to go home, as in we have to analyze everything little by little before questions will start coming up.
Okay. Yes, that's fine. So we all have the information. We don't have time for me to do the regression part, but anyone that has sort of understanding can go through the files as well and try to understand what is there. So in terms of the project, it's not fully ready yet. So I've started creating, because my computer crashed and I lost my data. So I'm doing that again. But I can just show some of what we've got. So the first exercise will be on data visualization, where you will use this flower data set, the Fisher Iris data set, to do box plots comparing the 3 different types of flowers. So the Setosa, Versicolor, and Virginica. Create box plots showing how the petal length and width compares for all 3 of them. Then I would also write a classification problem where you can try to create and find a model that works to classify a certain type of data. So we're going to release this exercise, let's say by tomorrow morning, and then we'll give everyone about 48 hours or we'll give everyone up to next week, because I think people need time to go over and understand MATLAB first. So I say, if you can submit the solution to the exercise, so for the visualization, all you need to submit is, save your created box plots and some of the analysis you've done in terms of the differences, the way I did it for the school subjects part, where you can look at what is, what's the range, what's close together, what's the average. So just make some simple analysis like that, save it as a PDF file, and they can save it on the Google Classroom. I think Augustine will show how you can do that. For the classification problem, just produce your confusion matrices for the validation and the test data for the 2 different types of models that you've decided to use, and to tell, to see which one is better. So once you just submit that, you can get your certificate of completion. So we'll release the problem set latest end of day tomorrow, and then you would have about 7 days. We have till end of next week to complete it.
All right, thank you to everyone. It is already 4 o'clock, and so we'll keep to time. So I want to especially thank Dr. Khadijat. It has been a great one with you. I was thinking, as in when we discuss about MATLAB, I was thinking what she knows about MATLAB was little, even when we discuss at length. But what I've seen now, I've seen that, man, this is very great. And probably we have to go back to do more work so that we can have questions to ask when we get hooked up somewhere along the line. So I think for all of us, we have to go back to do more work. And if we do more work, it is important for us to know that anywhere you get hooked up along the line, either installation, you want to do anything again, already on our box. It seems I have a little network issue. Can you hear me, please?
Yes, I can.
Okay. Our group is already there, so I urge everyone to just join the group. While I once again thank everyone for participating on the platform for this training. I urge us to go around to learn the MATLAB ourselves. And if you have any question, you can contact either Dr. Austin, Dr. Khadijat, or myself. We always put you through. If you have any complex one, just put it on the group. And we have our Google Classroom. Any support you need there, you can put it there. Someone is always there to give you assistance almost immediately. Someone is always there to give you assistance. And we'll always meet. We'll be having this kind of workshop before the year runs out, a more complex one, because I think by then most of us would have been used to the MATLAB. So have a more complex one, we'll do more complex design. All this that was done today was basis of MATLAB. So by that time, we'll be doing a more complex design on MATLAB, and you'll be seeing what industries use MATLAB for. Our next ARN training, our next ARN workshop will be on SQL query language, that is SQL database management. SQL is used for scientists, for engineers, for software developer, for data analytics. It's used basically across all sectors. It's used to query, it's used for data query. Basically, if you are dealing with large data, Excel cannot accommodate more of the large data. So if you use Excel, which I've done, basically, if you use Excel, you get to a point when the Excel will just have to crash, because you have to wait for like 20 minutes for it to load. And after 20 minutes, we click one again to wait for another 30 minutes for it to load. So we have SQL database management training workshop. It will be coming up very soon. So I urge everybody to join ARN, as Dr. Austin has rightly gave introduction about the ARN. ARN is African Researchers Network. It is for everybody. He has said that they have little token for membership, but it's not mandatory for anybody. If you feel you can't do that, just join as a member. You have a lot of privilege for us. So I want to call on Dr. Austin Fariola to close the group with the concluding rights.
Which other one? You're giving me title the title. Basically, we really appreciate this, because this workshop is very rich, and we appreciate Dr. Khadijat, as my brother Ken have said, that because she's put so much time and energy and everything. And we also thank the participants, because we have a lot of scholars in the room. We have people like Dr. Monica, we have people like Namdi, and we have Abel, and a lot I assure you, Dr. Khadijat, that this workshop is, you are training trainers. So you have trained, we may be few here, but you have trained more than 500 people today because of the people that are here. And we assure that we continue, as Ken have said, and we hope that when we call upon you, that yes, your trainees, we have grown to this point, we're inviting you again to take us further. You will also be disposed. We can't pay you because we don't have the money, but God will reward you. So thank you very much, and have a lovely evening to everyone, including our dear brother Ken, who has always been playing a serious role behind for more than a month with Dr. Khadijat in preparation for this. So we look forward to the SQL Servers workshop next month. Bye.
Thank you. Bye.
Bye, Monica. Bye.
Thanks. Thank you for having us.
Bye, everyone.
Bye, Doctor.